Oh, my mic is on. All right, there we go. Let's get started. Pop out the YouTube. Reload. My glucose level, I think, is in the ceiling right now. Pump will automatically deal with it, though. Synth, finishing up PCB. Bunch of weird noises. Go to the chat in here. Look at that weird shoulder. All right, let's see. This, hop out, chat, and then I can close YouTube. And now we have YouTube up on the screen. So much prep. So much prep. I don't know how streamers with a single monitor do this. I think Adam Plays is using something similar. I don't know what he has that does his dual chat, but I can't do it without having 16 different monitors attached to this computer. Start soon. There we go. Put that up just so that you guys know that we haven't quite started yet. And I'm in a house that's full of people, so I'm going to be talking quietly today, unfortunately. I do not enjoy when there's just people here. If I got my own place, then I wouldn't have space for this shop, so fun times. This is Younger Brother that we're listening to. It's a flock of bleeps is the album. All right, let's see here. What else do I need in order to make this circuit board? I don't think a lot. I think I've got most everything I need. Fusion is already open. I believe it's updated. Let's open up the actual. So we're doing the RP2040 VCO, and we're doing the actual one that does the chords. Now, the one that does chords, I finished. Thanks for stream is still up there. Wait a minute, why is that one still? Oh, because this one hasn't, the page. That's all right. It'll go away eventually. Yeah, I was sick last week. I was sick. I felt gross. I decided not to stress out my voice. Actual chord VCO. Now, while this one does have the 6U VCO chord is the one that we're looking at actually. Actually, that's the front panel. That's the whole thing with the front panel. This is the other circuit board that I designed, and I pulled it into the original model so that it would all meet up. And I'll open this one up too, because it's not done, but it is kind of done. It's, you know, a circuit board you can look at for a year and still come up with stuff that you've forgotten to do. That button just doesn't have an extended push on it. That's just the 3D model that I used, but the one that'll go into the actual thing will have that long thing on it. And you know, Hajiwo doesn't put any LEDs on his stuff. I feel like I should add an LED somewhere. But his whole entire purpose behind it is that it's cheap. We got to do some measuring too. Hey, Wayne Johnson, how you doing? Saw you in Carhole and Gonad stream. How's it going? How's it going? Let's open up the other file. I'm not going to be very loud today. I know you guys are accustomed to me hollering like TechSmith, but yeah. Front panel as 4 LFO. What's that, Marco? This is yeah, I mean, actually, these things will be able to be, you know, VCOs, LFOs, whatever I want them to be, actually, because it's just an in and an out. It's not multiple outs though, so I don't think I'll specifically use them for control voltages. But since the RP2040 has the analog, you know, the D to A on it, and I guess it's got a pretty good one. 2 LFOs as a clock. Would you have them fight one another? Would they like duke it out in the streets? Yeah, I have Marbles. Marbles is one of the boards that I built up from a circuit board, and I guess that would function. That one functions almost like as the brain of your entire operation, because that does do your rhythms, and then it does off, like it'll do offbeat stuff. It'll do like a catch up, like a drummer would. And so all of the, hey, almost an engineer, all the setups that I've done on the modular synth with Marbles sound like marching drums. It's like bump bump bump, ba-da-da-da-da-da-da, like that kind of stuff. I don't know what that means. Funk is a push to invert phase. I don't know much about modular synthesizers. I'm coming into it with a sort of a newbie perspective. I don't know what's going on. Where's my 3D model? Oh yeah, there's the 2D design. So the two-dimensional, oh, okay, never mind. The two-dimensional design looks way different because you start using all of your different views when you put together the final stages of a circuit board. Hopefully we get to this stage today. Not all there. The quote in this song, you may have noticed. I love it. Anyway, the putting down the ground plane is like sort of a weird thing that you do on circuit boards like this, and you try to distribute your ground so that they get to everybody. Hopefully it's something we get to, because it's something that people ask me about. But yeah, then you can go to the 3D model. And you can take a look at what your board actually looks like. I was always, in the past, I was always surprised by what the board looked like. Mustard, don't let's be silly. Where is the model? Did it not open up with everybody else? I guess it did. It didn't. This is the one that we're working on. Same exact size of board. I just need to figure out where all this stuff's going. Theoretically, I should have room for it, but I had to totally blow up the entire board and start it over again. Oh, and I want to look at something that's in marbles. What happens when you don't have enough amps? You short one of the amps to keep it stable, but do you do it in a feedback, like a unity feedback loop? I think you do. I'm not sure though. I want to take a look at somebody else's design. So do we have an extra? Yeah, we do. Okay, so it's ground the pin, and then the amp is unity feedback. Okay, so now I know. Now I can close marbles. Yes, yes. Everybody go away. All right, there we go. And now I'm looking at the actual RP2040 schematic, and I'm taking this amp. Where did I put it? I thought it was in here. Oh, this is the wrong one. Actual chord VCO schematic. And then I've got this one here, and I just need to ground that pin. Flip, 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 flip. There we go. That's a weird maneuver to do, because you have to center click the mouse while right clicking. There's a CV2 pilot, another oscillator, an LFO, put a cable, and magic is to use the sine LFO. All right. Man, I don't know anything. Let's copy that ground and put that here over here. I don't know nothing. I'm just getting into this. Julian is the one who's getting me into modular synthesizers. I'm into building circuits. All right, I'm gonna save that and put it aside, because we're not actually starting. I know that partner anniversary thing. I don't know if that's actually today or what. Boy, I have been partnered for a long time. It has been a while. I could pop off at any minute now and go viral and totally be popular and cool, and then everybody will clap. Let's get this out of the way. That's as small as I can make it. Just sneak it under the panels. I've made the panels a little bit smaller not totally recently, but the videos that I'm uploading, the panels take up about half of my screen space. That big glitch is the chat coming into the stream. I don't know how to make it not do that. We only get the party hat, don't we? What's up, Blue? Count created July 16th, 2012. I've been tier 3 subbed for 78 months, which is the anniversary. 78 months ago is when I was able to be affiliated with the platform and actually allow you guys to give me money. I have 1,000+ messages, and I don't even talk in my own chat. Verified. Oh, there's a Twitch verified user. I don't get anything else though. I need to do sub badges, don't I? We need to do a lot of that stuff. I need to do a full like nose to tail update of my streaming stuff. It's been about time. maybe, I mean, all of this stuff is like, you know, when am I going to take apart the milling machine? When am I going to do all of my stream? Why is that up? Wait a minute, that should be the chat. Oh. It said it again. Did I just send that? I don't think I sent that. Wait a minute. What did this? Now is the time to now. There we go. Okay, yeah. So that is up to date. Did I just send a partner? I don't think I told it to do that. I don't know why that popped up. Oh no, that was bad direction saying it. Oh my god, my brain. Okay, sorry. I have 1,000 things rattling around in my brain right now. Anyway, yeah, the milling machine. Wait, no. Look at this. Hold on a second. I never did that. It's not in the regular Twitch chat. Look. It's not here. It's not in there. Where did that come from? What is that? Wait a second. I am going crazy. I'm losing my mind. I don't know. I don't know what happened. I'm out of control. I don't know. That's so weird. Very strange. Anyway, I'm saying, like, when am I going to take apart the milling machine over here? That needs to happen soon because the DRO is still broken on it. And I think most of this stuff is pretty much just waiting for burn the subs to get done. My computer exploded. It didn't actually explode, but the spring that I put in the water line as a stent to keep the water line from crushing on a turn, that wasn't as well coated as I thought it was. And I probably would have been doing good if I had thrown it in to the nickel plating setup when we had that. Permanently rotating camera. I could put a motor on it, but then I would need a turnbuckle or whatever it's called. Bonk. I like this album. Yeah, but like my computer. My computer. It ended up having rust in it, and so I just put the graphics card back in the frame, which is all behind me. But the spring, I used the spring as a stent to hold one of the tubes, on a sharp bend. The tube was collapsing because it was a thinner silicon tube, and it didn't survive. It didn't survive that environment. It was not made out of titanium. It was a steel stent, a spring steel stent. And when I got it out of the computer 2 days ago, it was no longer a spring. It was black sludge. And a thin wire was left. I crunched it by pinching the tube and then washed it down the sink. That's how little it resembled a spring. And so I had this nasty stuff just permeating the entire computer. And so I brought out the brand new ultrasonic cleaner, and it turns out that thing is a Banshee. I might as well have stuck a bunch of screws in a tin can and shook them in my face for an hour. Because that thing is so violently loud. It needs to live in another room. I gotta move it to another room. Yeah, I guess what I can do is print something that goes around the spring. Let's take a look at that. Let's see if I can find something for that. I like this album. This is a good song. This is from a while ago, too. All right, let's see here. Of course, anybody, like YouTubers are not able to hear what we're hearing, and people watching the VODs aren't able to hear it either, because, and I'll tell you why. I'll tell you exactly why. Look at this. Copyright, 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 copyright. I can't monetize any of this. Not that they're getting views. I mean, 26 views is pretty cool. You know, every now and then a stream will go up and I'll get a couple views out of it. But I don't know if people want to watch me playing games 2 years ago. Yeah, like zero views. 0 views, and I get water all over my desk. What did I do that for? But anyway, yeah, these are going up just for posterity. All right, let's see here. We'll try Thingiverse first. Stent. I'm gonna put a 3D print in my body. Okay, nobody quite knows what a stent is. tube bend. I don't know what the keywords are going to be for this. Tube support. Bowden tube bend support. Airsoft. Always airsoft with you people. Micro centrifuge tube opener. That's kind of neat. Oh no, I can't hum the song because then I'll get a copyright strike for humming. We're not allowed to have music in our lives. How much effort to DIY in your favorite CAD? Not much. I mean, you do, I don't know, like a something along a path, basically. You'd make a three-dimensional path, and then you would extrude over that path, and then plug it full of holes. I don't know. I would rather wrap a pattern around it, but I mean, I could 3D print something, or I could just find another spring that'll go on the outside of the tube. Not allowed to have silence if somebody makes a song and copyrights silence. It's 3 minutes. That sounds like something somebody would do. Maybe like tube bend support. The more keywords I add, the fewer things I'm going to find. I don't think a lot of people are printing for this purpose. Obviously, making it wouldn't be too hard either. This guy in his rocket. Keep seeing him. The random noise portion of the song. I have one of these clocks. My brother gave it to me. Let's see. Worm drive filament extruder Bowden something. Not quite my tempo. Not quite what I'm looking for. Happy partner anniversary. Thank you. Thank you. For the stent. Get some stainless steel and a wire and twist it around a screwdriver, then stretch it into a spring. I've done stuff like that before. It doesn't make a great looking spring. If you do it just right, it's good. Screwdriver is too small for my purposes. It would be I have tube that I like. Well, brass tube would maybe be a little bit too weak, but I do have tubes that are about the outer diameter of that thing, and I could I guess make my own spring. But I do also have a bin full of springs, so I could use one of those. It's just the inner diameter spring was a great solution. It just was not protected against water, and it took a little while. You know, it was a couple weeks. Nozzle for shower hose to clean. What the? That stuff's quite what I'm looking for. There's a printable machine for making springs. I gotta look this up. Everybody wants to complement the Nixie tubes with blue LEDs. I think they look good enough on their own. Let's do spring bender. Spring bender. What are spring bender? That looks like a mixing console. Roland Juno 106 bender wheel. What? Oh, that's the bottom thing. Oh, I see. Good stuff. And just the statue of Bender. And then there's roller things. Spring Factory version 1. What the heck? Oh, that's kind of crazy. So it looks like they're making magazine springs. Huh. Kind of cool. I guess you still need the bending form, don't you? Helicopter collective? Oh man, that would be cool. That would be cool to have. I don't have space for something like this, but that could also be my parking brake in my summer car. What's the tube made of? It's a hose. It's just a hose. That'd be cool. Okay, hold on. I'm bringing it back over here. Specifically, let's see. This would be an overlays, and then we get rid of the rack view. There we go. Now you guys don't get your eyes blasted out. And then the tube itself is, where is it? Something about this era of psytrance where everybody discovered that guitars exist. All good. So what this tube has to do is perform a very tight bend from the processor to the RAM cooler, and I had all this stuff out of my computer because it all got rust in it. And then what's his face? Damn it! Why did I forget one of my own friends' names? I just blatantly forgot his name. ADHD Degenerate, that's right, or Degen, was telling me that I need to lubricate my O-rings, and I'd never heard of something so farcical before, but apparently it is a thing, and they sell specific material that's going to allow those O-rings to be protected and actually grow a little bit. But it's Molly Coat 111. This stuff is expensive, though. They call it valve lubricant. This stuff is mad expensive, and I bought this for like 20 bucks, and it's just this little tiny tin of it. Ridiculous. But anyway, the tubes are silicon rubber hose, black silicon rubber hose, and so this little tiny bend has to go basically like that. I can't do them straight on. I actually might be able to do them straight on, but it actually goes to this part of the processor, and then it goes over to the RAM sinks. So I can either shorten it and have it just sort of do a weird little kink. I decided to keep it longer and then hold it open with a spring, which was great. It worked perfectly, except that the spring corroded. You know, you get that little window of corrosion into the thing, and then it can grow for the whole entire, you know, piece. And it looked like it had a coating on it. It had a nice coating. It was a very shiny spring. But, yeah, it pretty much gave up the ghost. It's tough because this sits a little lower down than the processor. It's like that. And so it creates like a weird shelf relationship between these two locations. So the tube was perfect. The tube worked great. But going straight on, well, this would have like a fitting on it. Yeah. God, all this stuff is full of, there's like a light powder coating on things too that I've tried to clean off and I haven't been able to. Thank you, Conad. It's been a while. I'm very tired today, but we're gonna do a little chill circuit board design because I got a house full of people and I don't want to be too loud. It's not even that I can't be loud. It's just that I'm self-conscious. You know, when there's other people around, I would rather have like an empty house and then I can yell. Because yelling and being expressive is what streaming is all about. You know? Loud equals funny. But yeah, the relationship with this joint is like this. Roughly. And so that little height difference is a big problem. And then the fittings don't even, like, they're so close that I don't think fittings would do it. I don't know. There is a way around this. I can obviously solve this problem. I just need to be more creative. More creative. Maybe I can get some of my other fittings and do something, but there's not a whole lot of room in this area either, so. Mongolian throat singing. I could do that for a little while. The trick is you're trying to make a cavity with the upper part of your mouth, so the overtones come from up here, and your throat is making the lower noise, so it's like that. Only if I was actually following a tune, it would be more dramatic, and if I was being loud, it would be even better. When I'm in the car and the radio is loud, I can do really good Mongolian throat singing. What was that song? If you like it, you should have put a spring on it. I did. One of the other lines actually has a spring on the outside. Here, while we wait, I'm going to put this stuff on the computer itself. I just got to get the hardware over here. And ADHD Degenerate's going to be very disappointed in me because I have this stuff here, but I don't have this stuff open again. And I kind of don't want to open it up again. So I'm not going to end up lubricating my O-rings. But when the time comes in the future, I'll have this. I don't even know if the time's going to come in the future, though. Why did I buy this? Why did I buy this? He just, like, forced me to buy this stuff. Fucking Molykote 111, valve lubricant. Good for O-rings. But I'm not doing anything with it. Let's just pretend this never happened. Let me go get the computer. And the hardware. Wee wow 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 wow. This is a weird album. I like it though. Music to have a really bad trip to. Like, just the worst. Let's see, what was I getting? Oh, thermal stuff. You guys are going to be real disappointed in me at this thermal stuff that I'm about to do, because I ran out of thermal goop. All I got left is Arctic Silver 5. And I'm going to leave the stuff that's already on there, because it's fresh. It was done, what, a month ago. Look away, computer enthusiasts. None of this is going to really gel with you. Hardened ancient Arctic Silver 5. Thermal Nutella. As long as there's stuff there, I could spit on this and it would do well for until the spit dried out. This album is so weird. Oh, it looks like the wires are this way now. Oh, that's alright. This one just has to do a 180. Let's get that under the screw. Let's go this way. I actually have to take this apart if this doesn't fit. Oh no, this fits nicely. Actually, it goes over here. Robot noises. Alright, that's where the processor goes. Springs keep these tight. Keeps an even amount of pressure on the thing as if these loosen at all. Ah! I wonder, is this a speak and spell? I wonder if that's what that, I think it is. You get all kinds of weird stuff out of a speak and spell if you circuit bend it a little bit. I have several. I have two, actually. One of them is just a circuit board at this point, and I don't think the screen works. So I was hoping to get the chips off of it and use those, but there's actually an Arduino project to make a speak and spell, but it's doing it in, like, the math. It's not actually using the TI chips that are probably discontinued at this point, but water-cooled speak and spell. Why? We got water cooling out of our system. I did the insane water cooling thing. I'm water cooling the M2 drive and the chipset for no reason. I did the nickel plating. I did all of it. And then, what's his face? The one Australian machine shop YouTuber does a whole video on how easy it is to nickel plate things. I'm like, bitch, I know. I was there. What would cause a speak and spell chip to heat up? Doing more of the speeching, I guess? Speaking and maybe spelling a little bit? Perhaps? I don't think I need to totally tighten that down. It doesn't need to be super duper tight. And then the chipset. Oh, this is actually the wrong one. Let's get that off of there to begin. I'm just so mad that that spring disintegrated. It completely disintegrated in here. Just the worst. Makes me look bad. Makes me look like I don't care. At one of the LAN parties, a friend of mine was like looking at my computer. How's it doing? How's it going in here? And I'm like, oh, it's great. I'm like, oh shit, that's rust. I didn't notice. The lighting masked it quite a bit. Was that a flake of nickel? Oh boy. Ooh. I hate the BIOS reset button on this. There's a BIOS reset button, and it's designed to be pressed from outside of a computer case. And so what it ends up being is this little tactile button that sits on the back of the motherboard. So when I'm handling the motherboard, I hit this button and almost reset my BIOS settings, which is not good because I have a lot of stuff disabled that allows me to use the smaller power supply. It's not a good scene. Yeah, so the goal is to get from here to here without too much excess, and that's difficult to do because this overlaps. It can't hit that, which is why I went with a tube. Tighten that up and see what we got. Like a solid fitting isn't really going to do that because it needs to go up a hill. No, I haven't started. We're working on circuit boards today. We're not doing this today. This is a slow burn kind of thing that I'm doing here with the computer because I want to make sure I get it right this time and don't have to take it apart again. God, I'm so stupid. I'm the stupidest. There's not a stupider among us. Homogus. People don't really reconcile with stream starts soon. I should make another graphic that says stream is going to start in a little bit, and for right now I'm sitting here talking to people. If I recall correctly, this song is a banger, as the kids would say. Do I have just like an extender just to pop this thing upwards a little bit? Not really. I mean, like... Yeah, I don't like it. I don't like it. Alternatively, I could use something like this. Let's see if we can make that work. Hold on. I got ideas. Ah, that's so close. Lengthening it or shortening it are the only ways that I can go with this, huh? And all of my gender benders are used up in some other parts of the build. Let's see here. I mean, like if I bent some clear tube, I could perhaps make it, but it's a sharp bend for clear tube to make. And the regular tube just collapses, so that's out too. That's a fill fitting. I don't need that. Stuff in this bin is very disorganized. All right, I don't have a lot of options here. I mean, I think I have a female to female, but that's also totally useless to me at the moment. The rest of the water cooling fittings have gone in to burn the subs, so. And then doing it like this needs a very specific length. And it also gets rid of my style points. No style points for that. Yeah, like this is as long as I can go on that. And it doesn't, it fits inside and it doesn't quite do it. Although this thing can break down. I've had this one break down before. And like, it's just got 2 O-rings in it. And I trust it with my life. Oh wait, this one's a little longer. I wonder, well, how do you install that? Oh yeah, also it won't seal. It's just a little bit wrong. The O-ring sits just outside of it. Oh man. Look at that. The world is cruel and unfair. Plastic bends in parallel and have the silicon tube go in a U shape with longer tooling. sorry, tubing. The sidewall of the case is right here. The sidewall of the case is right here, so it has to fit in the footprint of the motherboard, unfortunately. Man, I'm still not feeling totally well again. Quick little, like, weekend bullshit sickness. This might work. Without this. Oh, there's little noises in the background of Psytrance. Good Psytrance. I need this to come out at a different angle. Why isn't it cooperating? This isn't good. No! This is killing me. This way? I can't do this way because this has to have another fitting right there. Or like that way. That way's out. Sidewall of the case is right here. If I reverse the entire processor thing, then maybe I could loop it around this way, and then I would have a bend of slightly longer tube that would be like this. But that would cover up everything. Also, it's still kinking. Going this way. Yeah, it's just doing a U in general requires a lot of space with this very, very weak tube. Very weak tube, this is. Weak, weak, weak. It's like I don't want to totally wrench this down. Oh yeah, I remember this song. Hold on, I haven't listened to this album in a long time. Where's my big Allen key? Alan! Where's Alan? Alan! Alan, I'm so lost. Here it is. Okay, I found it. Big Allen key. This thing just lives with the computer now. For like a month, I kept topping off the water supply. I don't know where all the air was coming from. I just don't know. But the thing was sucking in air. I don't know where the water was going. One chat member theorized that maybe the radiator has some kind of a hole in it, which is possible, but at least it wasn't letting water out. But I don't know how it was getting in. I kept having to like significantly top it off. Very weird. Wire-eared. All right, let's see if we can make a nice little bend here, and if it'll fit with the hard tubing. And then I can still have my fancy fittings on it. Like that. That's pretty good. Nope. Damn it. I can curse this shit. God damn it. Why can't we have nice things? Why do you continue to disappoint me? Ribs! What does a skeleton have for a snack? I love that one. That's a good fun one. Ribs! Alright, I'll try this. Try lengthening it. No. Nope. I would need two of these things, two of these bends, if I was to do that complicated shape. That is obnoxious. That's really obnoxious. Unless it's for something groovy. Yeah, it just doesn't work. It just doesn't do what I want it to do. Well, more elbows. What if I go directly to an elbow and then down to the fitting? Just trying it. It doesn't have to. It's suggested. EK wants you to have inlet outlet, so the inlet goes directly to the spreader. Apparently there's it really is splitting hairs, but it does just perform slightly better when it is in the proper direction that they recommend. Too short. Try the mid-length on this. Yeah, we read up about it when we were building the computer a couple months ago, and EK was saying, like, it doesn't matter, but, and the but is that it just does ever so slightly better when it runs the proper direction. That's not helping me out at all. I hate it when the Titan location is in the wrong spot. That might actually work if I can get it to actually screw in. Might need the slightly longer straight section. That one I don't trust. That one's disassembled on me before. We're doing this because I got it on my mind. I think it's working. I think it's working. I think we cracked it. I think we cracked it. So the height change is taken up by this other elbow, which I don't like the look of it, but it's what I've got. And then, yeah, this is, instead of having a spring, I have this stuff in here. And everybody is pretty tight against their O-ring. This thing isn't being pulled in a weird direction. Hold on, careful. Because like it wants to tilt this heatsink backwards, which would unseat it from the MOSFETs, which would not be good. It's barely held on to those MOSFETs. It's not very strongly held. I guess that'll work. I guess that'll work. It's better than what I did. It's just an elbow and then an extension. And this one would have been too long, because that'll start to push this out this way. Oh, that's not... I could probably put this one in there. What's that? What would that do? That would push this out this way, and it would make this angle worse. So, but this is kind of restricted in here. I need something in between these two. It seems like the ideal distance is like there. So would it be better to put the other one in? I don't think so. I guess this is fine. Is the new computer... No, this is my gaming computer. This is the one that we put together a little while ago, where we did all the work, nickel plating stuff. I will pressure test it, but I'm not going to be all that crazy about doing it because I know this build, and I know that it won't leak if I properly tighten stuff, which I have. I've got the brake tester that I could use, but I don't know. I'll play that by ear. Play that one by ear. We'll see whether or not I feel like I need to totally pressure test everybody. I lose the uniformity of the look. I'm disappointed in that. I like these things. No, we're not gonna do leak testing today. We're gonna work on this circuit board that I need to finish because I want to order them. I want to get them ordered. This is just my time for not projects. Actually, this one gets a specific... I don't think this one goes there. Hold on. These are tough to work with, these things. Yeah, I know. I'll run it and I'll look for leaks, but everything's down to this, like... This stuff is so surefire not gonna leak. Because water cooling, they've taken down to a process. The G1/4 fittings are so much less ornery than... what things used to be like. This tube is the one that actually goes here. Goes like this. The LEDs indeed made it go fast. The LEDs hid the problem from me for so long because everything was lighting up. I didn't notice the rust. There's actual rust in my water lines. Crazy. Crazy, crazy. All right, anyway, this goes back to where the rest of the computer is. We solved the underlying issue that destroyed my build, and I'm going to be putting opaque fluid in there just so that all of my mistakes aren't laid bare for everyone to see. I had this stuff down to its bones, completely disassembled, and I put it in an ultrasonic cleaner, and it still didn't totally clean it up. There's still like a film on everything. I don't know what to do about that. I'm not going to sit here and scrub everything down. And I did. I scrubbed this down. Thank you, Keeper of Maps. Yeah, it is my sub-anniversary. I have no control over that. That just appeared. But yeah, fucking, like, just a film on everything. And an ultrasonic cleaner did nothing. I get no breaks. Nothing. Oh, 3-day binge. I don't know if I like this solution, though. This is putting pressure, mechanical pressure on things that probably shouldn't have mechanical pressure put on them in the directions that it's going. But I guess in the grand scheme, it is very minor. It also looks like ass. It doesn't really match. I mean, the look of the thing, I guess, I don't know. I've seen hard tubing builds that look really good, though. I kind of like the hard tube look, but that's not what I'm going for. Ultrasonic cleaner was making a lot of noise. Yeah, no, this thing is definitely an ultrasonic. It had good reviews on Reddit. Good reviews. And it is an ultrasonic cleaner, but it sounds like you trapped a dentist in a metal fridge, and they're trying to escape using only their dental tools. Bop, 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 bop. Film or scratches, it's film. It's an actual physical film that's there, because I can take a paper towel and scrub it off of some of the surfaces. I think it's there from the aluminum electroplating, because originally the original version of that MOSFET cooler was just the aluminum heatsink that I flattened and put a fitting on, and I didn't think, you know, I probably should have done that every now and then. I didn't think, and it did a half-cell reaction with the nickel. Apparently aluminum and nickel are not friends. You know, you can nickel plate stuff, and then it's unreactive in the presence of copper. But yeah, the copper and the nickel and all that stuff, it blew up. Bother submitted to the PCB life. Yeah, I gave in a moment of weakness, and I designed one VCO already, and we're gonna do some of the second one today. But yeah, the electroplating happened between aluminum and copper. Nickel and copper are fine. Brass, copper, nickel, those all play nice. But I didn't think aluminum would be so reactive. Aluminum is a pretty reactive metal. And so it plated some of the nickel upstream. And I think that's where the film comes from, because it's not a rust film. But that's not the problem, because we did the whole nickel plating thing. And I nickel plated a copper heatsink pad, right? We did that. That was fun. The problem is that I used a spring as a stent inside of a tube, and we just figured out how to use elbows. I'll tell you in a minute, Hidanika. We used elbows to make a not great looking, I'm gonna cough, and I double bounced on the button. We used elbows in order to make that little PCB bend, but the problem was that originally I had a spring in there as a stent, and it completely disintegrated. I thought it was a coated spring. I guess maybe it was a coated spring and it just disintegrated anyway. So yeah, not doing that anymore. I like my crazy ideas. It's just because I have crazy ideas, they blow up in your face every now and then, and you have to deal with them. So I don't know what process put this white film on everything in the water system, but I've been trying to clean it out. I've been using the ultrasonic cleaner to clean it, but that makes my ears ring. I need to put that in a different room if I'm going to do like extended cleaning or like PCB cleanup and stuff like that. That thing's out. It's not going to be in this room, because like it stopped and my ears continued to ring. It triggered my tinnitus and all that stuff. Remember, folks, it's tinnitus. It's not itis. An itis is an inflammation. Tinnitus is not an inflammation. Medical terminology is very specific, and everybody says it wrong. But anyway, so I tried the ultrasonic cleaner, and it did not clean that out. It didn't do it. Plus, I'm not supposed to put acrylic in alcohol. So, whoops, I should start listening to the materials scientists. They're smarter than me. Anyway, so there's this white film on all of the water cooling stuff. I scrubbed everything I could. I even took a toothbrush to that reservoir and it still looks like ass. So I don't know what's going on with that. I just don't know. I just don't have answers. Smarter or been there, done that. Maybe they've been there, done that with some different stuff, because I know ADHD did a corrosion lab in college. He had to make this whole acrylic thing that had like materials in it. I think it was battery related, but still. There's some smart minds working on batteries. Batteries are kind of a big deal. This thing would be awesome to build, but I'm not looking at that. Oh yeah, what is PCB life? The PCB life very specifically is that we no longer need to perforated prototyping. We don't need to do this anymore. This stuff. We don't need this. We can just design PCBs, because this board probably costs almost as much as a professionally printed PCB. These companies have completely not circumvented. I'm looking for a different $10 word there. They've completely overtaken the process, and the process used to be napkin to schematic to perforated prototyping board to napkin to solderless breadboard to perforated prototyping board to professional PCB. But these become so inexpensive, you're just going directly to there. That interstep of putting stuff on a perforated prototyping board and all the skills involved in working on this stuff, they're gone. The only reason you'd use any of these skills is to make your prototype design actually work before you do your version 2. Yeah, everybody quotes the price before shipping though. It's like 25 bucks to get 5 boards from China, at least. I don't know. There are other people have other processes though. I don't think I've used PCB way. Seed Fusion is what I use, and their solder mask, or rather their hey wonky robot, their solder silk screen layer is just a little bit blurry from Seed Studio, but I don't mind it. They make a very quality PCB. That's where this one comes from. You get free shipping. That's nice. I don't have super streamer boy perks in the engineering world. I wish I did. You know, like you watch these YouTube channels and they've got like the most awesomest Tektronix scope, and I email Tektronix and they don't even reply. They don't give a shit about me. They do not care. Streaming numbers are different from YouTube numbers. Yeah, this one was Seed Studio. And they did a pretty good job on it. I don't think I'm going to get the matte black service from them, though, again, because it makes troubleshooting difficult. These were really ridiculous parts to work with. I had to make special adapters for them in the perforated prototyping board to test if they'd work with these transistors, and then I got too into building the PCB, and by the time I got this whole thing together, max throttle was not max throttle. This is made to just be an H-bridge motor controller for as small as possible RC, but I wasn't getting any power out of these transistors. They were like new super duper MOSFETs from DigiKey, and I got the super duper MOSFET thingies to make the MOSFETs do the MOSFETting more, and it didn't work out, and I'm very disappointed in this. It was a big waste of my time. I guess you know what? That's what we do here. We waste my time. My time is entertainment for other people. So in that sense, I suppose it was not wasted. Use their fab to make a breadboard? No. Why? No. Anyway, yeah, PCB life is designing PCBs directly. And it's not like an agreed upon terminology. That's just you know, welcome to the new process. Welcome to the new process. These bins are meaningless. They used to be categorized. Also, I broke one of the frickin' fittings when I was taking the thing apart. This one was in there so hard that the little pieces of metal that hold up the cap broke off. These things have four little pieces, and all the rest of it has been machined out in order to facilitate water flow. But this thing was directly this thing was blasted by all the corrosion, which I don't know if that had any effect on the underlying aluminum, because the thing is completely coated. It's coated everywhere except for where I've scratched it off. But yeah, that's the stuff that was in my water line for the PC. Yeesh. Nasty stuff. Right now, the copper radiator portion of the computer right there, it's sitting for a couple days with vinegar in it. It's got vinegar in it to break down the rust. So, yeah, listen, I didn't listen, and I thought mixed metals in the water loop. Everybody's going crazy. They're just worried. They're just, you know, crying wolf. There's nothing behind these claims. There's so much water in between them, and the half cell reaction is not that. I was wrong. I was completely wrong about that. Mixed metals in the water loop, especially when you have copper radiators, it's bad. It's real bad. It's real bad out here. Call mom. It's bad. It with the presence of just a little bit of aluminum in the water loop, it corroded like immediately and caused problems. So live and learn. Live and learn. I thought that the spring that I put in as a stent, in order to keep this little tube was performing a bend that was too much for it. So I put a spring inside of it, steel spring. It held out for a while. The coating on it held out for a little while. But then the lighting in the loop masked all the brown that was appearing in the graphics card water cooler. The spring had disintegrated to the point where when I took this out, it would crunch. It made a crunch noise. Not a noise. It felt, you felt a rusty crunch when you pinch it. Bad. I didn't know that was, you know, a possibility. I think if I were to do it again, I think what I'd do is I'd get my nickel plating set up and really thickly nickel plate the spring, and then it would be fine. It would be totally coated and nothing would leak unless it got a scratch, which is probably how it went down for what. There was nothing left of this spring, by the way. It washed down the sink. I 100% disintegrated a spring. Yeah, the spring on the outside of the rubber was the other way that I'd done it. I didn't have a spring that was long enough to go on the outside of this, and the one that went inside of this was perfect. It was like perfectly shaped to keep this tube-shaped over the bend. We just replaced the bend with two hard lines now, and I have taken apart my entire water cooling system, save for this portion right here, and I've scrubbed it. The inside of these, I don't know what they look like, because that's copper. That's all the reactive copper that's been causing me problems. So I've got it soaking in vinegar. Vinegar has just the right pH to remove rust, and then I'm going to wash them out for a while, and then put everything back together. Gallium and aluminum. Gallium, that's where you put the little drop in and it makes like the big things. Will water not eat away any sort of coating? Nickel and I guess copper oxidizes. Aluminum has the oxidizing on the outside. Yeah, I mean, I don't know. Nickel is a really good corrosion resistance material. It's not very reactive. Brass is another good one. You see brass on plumbing everywhere. It infiltrates the crystal matrix of the aluminum. That's pretty rad. That's a cool thing to fucking say. The anodizing process is similar. It hardens the outside into sort of a hexagonal crystal structure that can actually hold dye, and that's why you're able to anodize aluminum and then color, you make it like look cool. Is the steering wheel getting linked to the CNC mill? No, it's just here. It's just here. I don't know. I don't have a lot of space. And so I have to make the most of this stuff. Yeah. I'm not sitting here making like car noises and shifting gears while cleaning stuff. I need to clean all this stuff out though. I need to get all this stuff out of here because I want to get Julian and Dave back in. It's been a little while. I want VCOs that I can throw at Julian and Dave too. I need to get a glass of water. My voice is not fully recovered. Hold on. I'll be right back. All right, all right, all right. Thanks, Pete Drop. Hook the steering wheel to BTS. I can do, yeah, you can do anything. You can do whatever you want. I could tear down this wall. I could punch drywall. You can do anything. Okay, yeah. Music. I like this album. It's a flock of bleeps from younger brother. But I'm turning this down. I'm hitting pause. We're starting the stream. I lost. I am lost. I have lost. And I'm a loser. Basically, the entire engineering process of circuit boards has been destroyed by cheap PCBs, and it is an embarrassment of riches. All this work that we've done to make this perforated prototyping board is wholly and fully useless. It is not needed. You don't need to do this part of the process anymore. You can skip directly to making a circuit board because it costs $5. If you breadboard out your circuit, what's up, Crowd Radio? Hey, thank you. If you do the breadboarding and you make sure that your circuit works, or like me, if you have hubris and confidence, overconfidence, you don't need to do the first physical build of your circuit board. Now, these are semi-permanent. You know, it's really for this technology exists in order to test your circuit out, but it also exists to build one thing and have it work permanently. It'll just be a little bit more fragile because there's wires and stuff underneath it. But again, like I've been saying, we don't need to do this anymore. This is totally and fully useless. You make sure your circuit works, and you can just jump directly to having it on a PCB, because this costs $5 for 10. It's not even $1 a circuit board. Ridiculous. These machines are, you know, they put FR4 on one side, and then a bunch of little designs are pooped out the other one. So, brain damage from the no tax solder flux. My brain's damaged. Yeah, anyway, so we're doing the circuit board design. Yeah, FR4 is that's the circuit board fiberglass, I believe. Yeah, it's like fiberglass goes in one side and the circuit board poops out of the other. It's ridiculous. So that's what we're doing. We're making them directly, and then I'm gonna have to figure out how to desolder the RP2040 from these boards. Man. So yeah, the stream intro, man, doing the daily videos for YouTube is great because it kind of gets you out there a little bit. YouTube's algorithm is a bit more forgiving than Twitch. Twitch, we've built up a big audience over a long time, but really that's backwards. I should be getting a whole bunch of viewers from YouTube stuff, shorter YouTube stuff. I need to start doing editing. Shorter YouTube stuff will bring in people and then use Twitch to keep the people. But on Twitch, we have music on the intros. You guys didn't hear it over on YouTube. I'm seeing a lot more YouTube commenters, which is awesome. I'm happy to have you guys here. Yeah, but apparently, like, on YouTube, sorry, on Twitch, the music is audible during the live stream. It's not audible on the VODs. And it won't be audible on the VODs that go up on YouTube because that's the YouTube one. And boy, howdy, let me tell you something about uploading to YouTube. It's your ass is just laid bare for all of the robots to look at because copyright, 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 copyright. It's a veritable orgy of record labels that are all wanting to get a piece of my sweet, sweet stream money, which is nothing. So it is ridiculous. Anyway, yeah, those may never monetize, but at least once I go through all that stuff, what's up, Dana Webb? Once I go through all that stuff, hopefully I'll be able to do a little bit of editing, and we'll get shorter videos on stuff. Yeah, RP2040 super intelligent. I haven't used it yet. Really? Wait, make people talk and Twitch. Oh, set up bot farms of RP2040s to engage in the Twitch and YouTube stuff. We ban bots here. We ban bots. So we already have this design, right? We've been through it a little bit. This is the actual cord VCO. Now, The cord VCO, I have already created a circuit board for, and I've gotten it all the way to the 3D render stage, which is kind of a cool place to be. You can make sure that all your mechanical stuff kind of works out. This pad is the same one that Mutable Instruments uses, and apparently it does fit. I don't know why this is like this. Probably because the leads bend a little bit to get in the right position. But yeah, I've fully created this circuit board virtually, and it's ready to send off. So the thing about these designs is that the two different boards are slightly different. This one takes 2 inputs to the RP2040 and 1 output from the RP2040. Whereas this one, takes 2 inputs from CVs to the RP2040 and 1 output. I know that might be a little confusing. One of them actually has a knob that can change stuff a little bit. And so what that means is that we need an extra op amp in here. So we put in a quad op amp instead of a dual, but unfortunately it's not exactly that simple. Putting a quad for a dual and then having another potentiometer, which is just biasing our -10 reference, that's going to affect things. So like this control voltage is a summation of an external signal and this -10, and then when nothing is plugged into it, I guess you've got ground bias coming in through here. So this would be biased in the center, and then it would be offset by your control. If you have an alternative control voltage, it will then get biased by this -10 line coming in. It's neat stuff, because with this amplifier here, you're balancing it out so that it can only be 3 volts, plus minus. So 0 to 2, 2.5, or whatever. We'll have to see what values for components I actually end up using on some of these, but I don't put values in the schematic. I usually don't do that. I would do a table of values somewhere else, and then my napkin sketch is where all the actual values for stuff is, because I'm only concerned with using CAD in order to create the physical circuit. And so I'm programming the computer program to tell me where to route all the copper. You know, values are not that important in here. If you do want to do circuit simulator, you can. I know that there is simulation capability from Fusion. I haven't used it because I was so burnt out from what do you call it? Whatever the common one was 10 years ago. It just wasn't good. It was like a programmer's practical joke against electrical engineers, because sometimes it just wouldn't work, and you would not change anything and hit the button a second time, and then it would work. Yeah, Spice, LT. I don't know if it had the LT back then, but yeah, the Spice circuit simulators were just crude and cruel and horrible. So I don't really do circuit sim. Circuit sim is fun. Fun is doing a lot of work in that sentence, but yeah. Anyway. Alrighty. So I guess those inputs biased to ground normally, yeah. LT was the one. Yeah, I don't understand. Well, no, I don't. I know that I'll never understand, but I mean, you hit a button and you tell it to simulate the circuit, and it goes, no, I can't. There's an error. And you go, okay, what if I hit the button again and tell you to simulate the circuit? And it goes, okay. It's like, what is going on? Anyway, we're doing the cord VCO, so actual cord VCO, and that adds this in here, which requires another amplifier in order to properly bias your control voltages against an external input. So, I mean, to be honest, like, I think this probably could be run to another analog input. Although you have 2 analog inputs and then you have the analog output. Yeah, this probably should just go to its own analog input, but I guess we're doing it this way. It's a bug amplifier. That's true. I've upgraded the computer processor. Oh, so it functions faster? No, it functions wrongly better. Anyway, yeah, so we are doing this circuit. I've got the schematic down. That's one of the struggles of doing this, is getting your whole schematic in here and properly represented. And then we have our circuit board design. So we're doing the fun part today. We're doing the lines that are going to connect everything together. And your job here is to make this, what's called rat's nest, look as clean as possible. You're trying to clean it up. So like positioning things so that they're in parallel with what they connect to. Right now we're looking at the bottom of the circuit board because this design is basically bottom up. It's all of the good stuff is on the lower layer of the circuit board. And the CAD program, Fusion 360 Eagle, helps you do stuff like that. It has various ways to help you out. So with the physical layout done, these, like the physical mechanical layout, the things that I am going to interact with when I use this circuit, those are laid out already. Like they have fixed locations. There's only one place for the RP2040 to fit. I had to move the power plug because that was too, it does not fit in between the potentiometers now that there's 3. So there were a couple little struggles there. You kind of tag down, you permanently include the things that you can't move, and then everything else is based on those positions. So the RP2040 sitting right here, I have nowhere else to put this. I could put it at a right angle, but that might cause some problems. I don't know. Actually, that wouldn't be too bad, would it? Well, no, it might cause some problems because I have lines that need to connect to the sides here, to either side. So yeah, doing it like that, I guess that just works. Sometimes the choices are made for you. Microcontrollers make it a lot easier. Yeah, they do. They do indeed. The analog circuits have been torturous to me. Software engineers, so the software part was the area I was comfortable. I work with my hands. My hands don't think too good. They don't like running. Yeah, I wanted to do, I like surface mount. I probably should have put this one on headers. That would have saved me a lot of time. I've got to extract the 2 that I put on prototyping boards. I'll have to maybe do hot air from above, and then it'll just fall off. Controlling the clock on our RP2040 with some TI chips, that's cool. Yeah, I haven't had much experience with the RP2040. The design that we're following is originally from Hajiwo, who is a YouTuber. Let me. I think I closed the page. Let's see if I can find it. Hajiwo, and Speedy Cat is the one who linked me to this. Hajiwo does very interesting, low-cost modular synthesizer stuff. This is directly linked from Speedy Cat, but Hajiwo is the originator of the code that we're going to use, at least. What I'm taking from it is I'm taking stuff from Mutable Instruments, and I'm taking the concept from Hajiwo, and I'm mashing it together, and I'm making these boards that can do a bunch of different tasks, actually, because they've got 2 analog inputs, a control on the outside, and they output audio. And the RP2040 is capable enough and cheap enough that I can do lots of these things. I'm going to have 20 PCBs, and I will build them up, hopefully leaving my friends with a couple cool things. You've got one controlling a plant light. Yeah, I can see myself using these a little bit more because they're so cheap. Would have put socket headers if I'm soldering stuff onto proto boards. I absolutely should have done that, but I was having fun. I was good. Look, they gave me the little Among Us pads, the little Among Us pads on the ends. Why not use them? So that's what I decided to do. But I had to put down a piece of Kapton tape in order to keep it from shorting on the pins below. Those little guys. These little half hole pins. Okay, so there's a lot of indecision in this part of the process. A lot of indecision. You're thinking, where's the optimal place to put this and that and the other thing? A lot of these markings and stuff that you see here are actually a holdover from the other board. I just basically did a copy of all the files, and then I figured out that I had to eviscerate everything in order to keep things. Like I want to keep my little heatsink grid here, but I don't know if that's going to last through the night. We'll see about that because the power stuff can almost go anywhere. It would be nice if it was in the vicinity of this thing. I could potentially put it over here, but I think I'm blocking some of the signal lines that are going to have to come out of this. I figured out on the other board that actually there's very few traces on the end result, on the end design. But when you're doing something like this, you lay out the things that are out of your control, the size of the PCB, the locations of the inputs and the outputs, the major players, and then everything else sort of floats around that. I start with structures. So we'll take one of the op amps and build up its circuit in a location. even before that, actually, before that step, you just sit here and you arrange the major players until your hardware is representative of the circuit that's there, and there are fewer air wires all over the place. So you're trying to reduce the number of air wires that are running around. You're not really going to reduce them until you start laying down traces, but you know, you try to get that to look a little bit less rat's nesty, and as you start building the circuit, all the complexity is going to start playing into it. Focus on the little pieces of it, get those to look good, then the major players can be connected to one another. That's sort of the way that I do this stuff. Thank you for the partner anniversary. That's totally out of my control. I could probably disable it if I tried, but how many years? I don't even know. I joined Twitch in 2012. 10 of these, got them on sale. Always find a use for them. $5 with the breakout board. $2 each. I don't even know what that is. I'm going to copy and paste it. I have to copy and paste because my social stream ninja thing doesn't like links. What are these? Oh, they're little prototyping things. That's neat. That's neat. Yeah, usually I'll plug this stuff like that into a solderless breadboard. Yeah, it all costs money. Hey, it's you know, I remember all the names. I've been uploading stuff to a VOD channel on YouTube now, and which is where the YouTubers are actually watching me right now. And yeah, I'm seeing all your names and stuff as I'm uploading this content. I hope people like it because there's a lot of it to go. I still have 250 videos to upload. All right, we got to start somewhere. I know. Hey, I've been regular on my schedule, so it's they add up. Oh, that's right. Okay, so I was doing some swapping on this, trying to, because the IC. So you don't have to do these things. A lot of these things are here just to like be nice and kind to the person that's building the circuit in the end. And one of those things is that having your ICs not have alternating pin 1s. I want all of my ICs, if I can manage, having them all in the same direction and having pin 1 all in the same direction. I don't like this way of doing pin 1. Why is that inverted? Wait. Okay, so this one's actually upside down. How did I do the other board? Wait a minute. Did I totally mess up my other board? Oh, it's going to be real funny when I discover. That's this one, and then we're going into this one, which is the one that I did. Yeah, my pin 1 is over there. Actually, wait. That's not, we're viewing it flipped. You hit F to flip the board. There we go. This is how it actually is. And yeah, pin 1 is over here. I think the other one was unflipped, wasn't it? Yeah, we're unflipped. So yeah, I kind of want all my pin 1s to be in the same spots. Wait a minute. I think I'm getting like turned around here because you hit F to flip the board. Why does it flip all the texts and stuff? That's going inwards towards the inside of the board, making pin 1. And then on the 3D design, I'm just seeing if I put my ICs upside down or not. No, they're the right way. Yeah, I want pin 1 to be towards the quote-unquote bottom of the board. So, all right, so you know the software is keeping me from doing these dumb mistakes like flipping stuff around. So many times that I'd be prototyping through hole stuff and just completely lose my mind about where pin 1 is because everything is flipped upside down. And it doesn't help that back then you would have a data sheet for like a transistor and they wouldn't even tell you if the view is the top or the bottom. Because sometimes they would give you a bottom view to help you, I guess, like when you're building something, know which pin was which from underneath. But then on the data sheet, you're like, what is it? But is it that way or is it flipped? And then yeah, it's a lot of stuff would explode back then. A lot of explosions, little minor explosions in the shop. But yeah, if I were viewing the top layer, oops, I keep hitting L. It would be F for flip. It would be this way, but we're looking at it this way. And there's my stripe marking for the stripe. I'll the markings are the last step. You're seeing the results of me doing the last step on the other version of this board, and I've got all my stuff, all my things labeled properly. All right, so I really want to put that power supply in there, but I think I need to build my two most complicated structures first, which are these two op-amp circuits, and then off to the side there are capacitors that are on the top layer. I don't want to select the wrong layer here. I actually need to take a potty break before we get rolling here. So I'm going to put potty break up on. Where's the where are my overlays? I need to activate like 500,000 overlays here. I had the terrible egg salad before stream. So I'm just going to put up a BRB. I'll be back in just a minute here, and I'll put music on that'll play on Twitch, but not on YouTube. Where did that go? There it is. Yeah. Let's see. And then put up just whatever. We'll keep it in a flock of bleeps, maybe. Like those physical boards are the same physical dimensions and shape as Arduino Uno. Ah, so you can go back and forth. Yeah, they really cursed everybody by doing that pin offset for the Arduino Uno. That was a real that was trouble for a while. Everybody hated that. All right, and then I'll put up BRB. Where's my overlay? You know, getting the overlays quickly would help keep me from having horrible issues with toss. All right, there we go. All right, I'm gonna be right back. I'll still be in chat. I'm back. Now I gotta just very gently fade out the music. All right, so anyway, our job now is air wires. We're gonna do all of the air wires. So we gotta make sure that the most complicated parts of the board have all of their connections. That'll reveal how I'm going to have to do the things like the power and stuff like that. So I've got sort of areas of interest that I'm going to focus on, and then we figure out how to connect everything to everything else. Another way to do it though is the lines that I want to be air wires just use high voltage. Yeah, there you go. Just crank the voltage up until the wires reveal themselves and kill a bunch of YouTubers. Those things where they use the electricity to make the patterns on acrylic have been killing a lot of people because they're not familiar with high voltage and how to handle it. I don't do anything with high voltage on my stream. I don't think it's a good idea to do anything like that in a medium where freaking out and being reckless is key. Freaking out, being reckless, overreacting. Those are the pillars of streaming, right? And you guys see, like, I struggle with reacting enough to stuff that happens on stream. I need to react more. I need to be more animated. I tend to be just like a brick standing there, not reacting to anything. You know, it's weird. But again, I don't do anything with high voltage because I wear my organs on the outside. I have an insulin pump, and we've done a little bit. I built a miniature Tesla coil once, and it reset my lights here. So I have no idea what the hell it would do to a bunch of RF equipment that I have on me, a bunch of Bluetooth low energy equipment that's running my pancreas. So we don't do anything with high voltage. I don't suggest you would anyway. You can go so far with digital electronics in doing cool projects that I don't even know why people mess with it in the first place. Makes cool patterns and it looks exciting, but it also slaughters YouTubers. It's ridiculous. So, all right, that was the wrong scene. That's the scene that I wanted. I need to figure out how to make this auto spin. Is there a way to do that? Constrained in free orbit? There might be a way. Somebody will come in and tell me that I can make it do a full, like, cool looking spin without the animation studio thing. There's a whole animate thing on Fusion 360 that you can do. I don't know how it works. So anyway, so yeah, the way that I did this one, start with this stuff and then figure out how it's going to connect to everybody. And then the power lines can be convoluted. The direct lines I want from my stuff. So yeah. No cool project places where I could practice this stuff. Fusion 360 is free for the regular license. There's a couple limitations on it that you can work around. The Seed Studio, this is the Raspberry Pi 2040 Xao, X-A-I-O, Xiao. And it's just a little miniaturized RPi 2040 with a bunch of LEDs on it. It's got a 3-color LED on it, as well as a one of these WS2812 jammies. 2 buttons on it and USB-C. It's cheap. It's really, really super cheap. So, I mean, like soldering stuff together and stuff. Yeah, I mean, there's not much out here either. I got a Micro Center nearby though. That's the one truly advantageous thing that I have that I can call upon. So what we're doing now is we're doing the 2-dimensional circuit board. This is the 3-dimensional circuit board. When you make your design, when you put all the parts in the schematic, it would behoove you to make sure that you have 3D models for everything, because again, this software has become so prevalent, software like this and this software has become so prevalent that every single component that in your design is going to have a 3D model. And it takes a little bit of time to get used to it and to fight the software into working properly. But once you get there, you can then spin your 2D design into a 3D design and plan stuff out, like the body of the board and stuff like that. So I'll be 3D printing the front panel on this thing, and then everything else is going to be built on that circuit board. So this right here is a functional finished design. There's a couple little things that I want to do, like checking on the width of certain parts to make sure that the model that I got from GrabCAD matches the actual dimensions of the stuff that I have, because I don't think it does. I don't think this conflict is actually a thing. The front of this switch hitting the front panel, I don't think that's a thing. I think the ones I have slightly different dimensions than these, and so as long as these holes allow for the pin to go through it, they'll be fine. So, like, for instance, the Donkey Kong connectors might be slightly in the wrong place. I actually think they are in the correct place. It's just weird that there's a different distance to put this leading pin on, the ground pin, for a bunch of different parts in the library. And so I took this 3D model and I actually pivoted this piece right here inwards a little bit in order to fit properly, but it still seems like it's, but these, again, I've already built a synthesizer with these dimensions, so they work. I just, you know, I don't know, it's just weird. It's the difference between the pads and the 3D model. Anyway, so I've got pads and everything that I've got. Yeah, I think maybe even these pins are a little bit bendable too, these interior pins. But as long as that is centered on this, I'm good. Okay, so yeah, that was the other circuit board, but now we're figuring out how this one's going to go together. This one involves a slightly different part, but it also opens up some areas a little bit wider for us. I don't think the heatsink is going to survive the build, unfortunately. I wanted it to, but this seems like a good place for me to put the power. I can just place it right next to the power plug, as long as we got access to these. That's a little tight. I don't know if I like that. That's a little tight. Well, that's actually, I think that's acceptable. Yeah, modeling all the solder joints. I've seen designs do that, and I think that's a little bit, it's a little extra. I don't know if that's wholly and entirely necessary. I could move these resistors up, but all that would do is free up the middle of this koala face pad. I don't think I need that to be free. And then this stuff here, that's all arranged properly. Yeah, all right, so let's start all the way down here and we'll see what we have room for. I want to keep components away from the edges of the board, and I put all the big stuff, the big capacitors, on the other side. This part of the circuit is the TL074, and what I'm looking at here is stuff is on the wrong side, because these are coming from over here, right? Yeah, that comes from over there. And so I need, for my gate, what is that one? 8, 9, 10, and 11. I think the unused one should be 765. So circuit A is coming from the other side of the, these go off into nowhere because there's actually a capacitor there. If we do the standard top view, you look at display layers. Yeah, layer names are updated. So if I go down here and I use preset top, now we see everything on the top of the board. And there's a capacitor that I added. That should go down to the bottom there. And then something out there. These are the power capacitors. And then this is the one that goes in between the two circuits. So this will probably live somewhere over here. I'm going to keep it off of the board for now. And then, oh no, those are the power capacitors. What's this one? What are you? You have to do with a different part of the circuit, huh? Okay. All right. I can work with all this. All right, let's go back down to the bottom of the board and start messing around with it. And I'm using curved traces because it's become a meme around here. Curved traces, much like curved swords. Those are not the grounds. Do I want to flip P6 around? If I flip it around and those are the, oh no, but that's 3 volts, never mind. Probably leave that alone. I mean, this probably doesn't need that much heat sinking. It would be nice if I could find a big clear area, and that would be here, but here is where the op amps live, because those are my ins and outs. Here be dragons. I wonder if I should move all of this down and then get this here. I don't know if it'll fit, though. And I might be over squishing everything. I kind of want to spread out on this board. Real estate's kind of hard to come by, though. Think about this a little bit. All right, I'm going to pull this out just for now. Just put that to the side. You can sit right there. Think about what you've done. And now I want to rearrange the actual gates themselves in IC1 in order to fit my needs. So pin 1s are going to the left-hand side. So I'll take this. The text is, yeah, okay. It's like that. So that's where pin 1 is. And then that puts first set of gates. I think is that in the right place? That goes there, 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 and then it goes here. This one is the unused one, and then these two. So I kind of want to do, I want to kind of, yeah. I want to swap them. I don't know how to do it. I think you can do it from here, but we'll go back to the schematic in order to do it. So I go back to the schematic, and then we're going to make TL074D is in from the plug. So I can just take these and delete them, and then I can invoke it from here. So invoke is a command that I just learned how to use. And then let's see, op amp A, B, oh, I see. So it's not even, I can't invoke it because it hasn't been put in here. So I guess if I just go back to my parts, well, I could also just copy this. And that comes in as gate B. And then this one will be D. I didn't want that. Wait, I just put it back where, Control Z. Copy, that goes here. And then copy that, this one goes here. We'll see if I got that right. Gate B, blah, 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 changed out. What the heck? Oh, did it place it? Oh boy. Oh, it copied the wrong, I copied the wrong thing. That was dumb. I copied the wrong thing. I copied the MCP. That was a bad move. That was a bad move. Oh, I deleted them from the other one and they appeared here. Ha! Yeah, see, I want the TL074. So delete that one, and then I want this one. So yeah, one of the TL074s is on the output and the others are on the input. Let's figure out exactly which ones they're supposed to be, because that's these two as well. So I want pins, basically I want them to look like this, look like the ins and outs. So CV in and the audio output. So audio output is the first, well, gate A is audio out. So I can go back to here. A is audio out. And we have it on D over here. So what I'll do, let me copy, place one over here, and I'll delete this one. Nope. Delete. Those are just the power pins. See, I don't know if this has a oh really? Are you just gonna make B's now? Is that all you're gonna do? Does that mean there's an extra one in here? Yeah. Fantastic. Thank you so much. All right, we're just gonna get rid of all of them. Just delete them all, delete them all. Everybody out. Okay, and then now we're gonna put, I'm going to place a component, and it's gonna be from my chips library. And we're looking for the TL074, which is the 4-gate version of the TL072. Guess what the 1-gate version is called? You can't. Where is it? TL074, right there. All right, so gate A is our audio output. Gate B is, well, B would be the trip back, but B should actually be from one of the CVs. So we'll take B as our mixing CV. And then C is going to be our non-connection. And then D is the one that leads back up to everybody else. Did I get that in the right order? Oh, I don't know if these are associated with the same gate. Let's figure out what happened. Do we have power and ground? N19, N12. Yeah, I don't think we have power and ground. We need to put that back in as well. So I go back to the schematic, and then I'm going to get these two and delete them. And then I invoke from this. I invoke power pins. There we go. Modify gate swap. Okay, I'll try that. All right, save that. That's funny. Oh wait, ground power in the middle. That's right. Yeah, there's 12 volt and VNAG. Okay, that's perfect. Okay, so yeah, still getting it weird. R17 is there. That goes to the MCP. This one is the dead gate, and then this one. No, I think I got it wrong. So you're saying go to modify, which is a tool. There we go. Modify, change, or gate swap. There's pin swap, but we're looking for gate swap, right? Orphans, line distance, join, isolate, hash. Modify gate swap. Copy format, lock, change name value, replace, and then pin swap is for, that's for pins though. Yeah, we're not allowed to do that. What's up, Brink? Yeah, I don't see a gate swap tool. By the time I figure it out, it's better if I just flip them manually. Okay, so this one's in the right place. Gate A is in the right place, but then I got to figure out CV in should be going to B, but it goes directly to the MCP. Oh, that's right, because it is. Yeah, that's correct. It does go directly to the MCP. Gate swap from the help page. Let me take a look. Let me take a look. How do I print a PDF? On the schematic design toolbar, click Modify Gate Swap. Modify. Is that in the schematic tool? Maybe because I'm in the layout tool. Gate swap. There it is. There it is. Okay, so we can do it in the schematic that way. Okay, that was the confusion. All right. So I'm just trying to think about the way that I want these things to run. Like CV in, I guess I can go down here for that. This one's coming from over here. And we're still using the big boy grid. Like those two on the way here. Because that's easy enough for me to lay out. But then the next place it goes is to the other side of the board where I can have the capacitor basically be like somewhere around here. I think the caps I like to do top to bottom, so that'll be like that. Then we have this one needs to go to D. So that one's actually C number 1. And that one is coming from which one? Is that, yeah, so D and I guess D and C we can swap. No, D and B? Yeah, I think that's right. Okay, so modify, gate swap, you. And wait, no, you're a different chip. Wait a second. Hold on a minute. No, B is in the... B is coming from J4. J4 is not labeled on the side of the board. Cool. Okay, cool. Yeah, one of them comes from the MCP, and one of them, this, like, which one? This one goes directly to the MCP. And so the one that doesn't should be gate D. And then we'll flip the other one. Okay. One that doesn't. Directly from the thing. Gate D. Why am I so lost? Yeah, maybe, well, gate C and this one's A going to the out. So I have that whole side of the chip is doing, let's go. And this is the other side, the C and B are the other side of the chip. So maybe C and B swap? I don't know why I'm so confused about this. It's just like, I'm so confused all the time. This one coming in from externally, but it's got unity gain because it's that key filter or whatever it's called. And then that capacitor, like these two, not too happy with their arrangements. That, maybe. And then those go to external stuff. That one's power in the middle there. And give that a little breathing room. You got to be careful because some of these look like they're making an attachment to one another. And then we'll go into these chips. Yeah, this is going to be tough. This is going to be a tough layout. All right, well, we just start somewhere, so let's just start with these. I'm going to bring these out and give them space. I'll give them a little room to breathe. That'll make it easier on me later on. Where are you? You're actually over here. B17, if that's your real name. And this one's the non-used one, which is going completely against how I thought I'd be able to rearrange these, but it's the MCP 6004 is coming, like this one goes directly into that, whereas this one now goes through the op-amp circuit, so we have to deal with that. All right, let's start laying out traces, I guess. We can just take this bit by bit. Now, I've been using 0.3 as my trace width. Actually, was 0.3 the larger? Oh, I love how it's not on the list. Well, we can force the issue here. So 0.3, and then I forget what the corner radius I was using is, but we were definitely using curved traces, so this will curve up those. Let me look at the settings for the other board, if those are still associated with this. I don't know why it dropped all of my settings. Oh, because I was working on it on my other computer. That's why, the computer that's in pieces right now. Corner radius. Negative 90. Great. It doesn't give me the corner radius, does it? So nice when it just lets go of any of your settings. I should probably play around with the grids too in order to get everything on like a metric grid, but I'm just not. I've been focusing on the design. We'll give it 1 and see how it does. Well, that's not going to reveal anything. Yeah, I think a 1 millimeter. Well, no, 1 millimeter, if I need to split that 3 ways, that's not going to look very good. So if I do, like, I don't know, 0.5 millimeter, that's probably going to look a little restrictive. I mean, that's okay. See, at 0.3, and then I go up to 0.4 for the power traces, just to give them a little bit of a little extra copper. Just a little extra something, something. So yeah, trace to pad, trace to pad. This one's gonna look bad. Can I take this and I guess that it's not great, but whatever. You gotta pick your battles sometimes. And then alternate grid spacing in order to get to the pad like that. There we go. So it's just, this is like the fun part. This is like playing a factory game and laying things out nice and neat so that you don't confuse yourself later on down the line. I don't like auto route. I don't know. I don't trust robots. And then we can do a fancy one here and do that, and then take that one down like that and go straight across. And that just makes me a nice looking little 3-way junction with soft edges for my soft signals. I could probably make that more compact, but there's a lot of space on this board, and it's kind of weirdly spaced out. This is going around like that. This is going to ground. We'll do, well, we don't have ground on this circuit, is a little bit weird. Okay, and then that's a travel trace. So we travel over there, and now we're over here. Yeah, making little roads that all the little electrons can travel on. Think, think, think. Oh, whoa. As things get restricted, I'll have to fall back on my various goals in laying stuff out in particular ways. Because, like, can I get around that connection? Where's that going? That's going over to our other amp, so that goes up. And I guess if it is traveling a distance, I can just take it from there. This is starting to be a little bit strange, though. Where's that one going to? That one goes to a capacitor, and then it goes over to our other portion of stuff. Okay. What is C14? I need to make sure that my decoupling capacitor is nearby. So let me take a look at which capacitors are associated with which chips. So C11 is going to the TL074. And then do we have... I don't know where the other one goes. C4 goes with power. The MCP... Oh, C15 for the MCP. So 14 isn't even mentioned in that. So 14 is actually associated with this stuff here. Well, I could put it there. The power traces can sometimes really confuse the design. If C11's right there, then I blocked it with this ground right here, which I can always take that from another. I don't want to use unroute. I'm just going to delete it. Because then I can take my two power traces, which will be 0.4. I don't like auto route. People love auto route. I don't like it. I like to, and plus this is the fun part. This is the fun part. This is where the fun begins. That really handily blocks that ground. Maybe we'll put the capacitor on the other side. That's getting kind of close, but we can actually bump this whole circuit down here a little bit. It looks like I should take this and make it a little bit further down on the board. Might be a little helpful. I'm gonna have to reroute some stuff, but dang it. Dang it, Bobby. Let's see here. All of you, come with me. We're gonna go down here. Oh, nope, nope, nope. Don't want to take that with me. That's one of my mechanical things that needs to stay put. Just give everybody a little room to breathe. A little room to breathe. And of course we need to delete this stuff and rebuild it. Yeah, I'm pretty proficient at soldering, so thanks for the partner anniversary. Wishes, well wishes, whatever. So now we can route these in 0.3. Or sorry, 0.4. 0.4 for the power. And there's a leftover trace I want to get rid of. And we're looking for the grounds here, so I can actually do this just straight across. Of course, that can go anywhere. I'll have to reposition that. And then attach these two with point... Oh. I do need to play with the auto router more. It has to be pretty functional for people to like it so much. But I generally don't use it because I don't like it. I guess that one can go like that. I don't like that cut off end here. Move that up, I guess. Nah, I don't know if I like it. I don't like it. Let's see. Yeah, we'll have to get ground in here too, so I need this to have a little bit of room. Maybe I should just bump it up a little bit. No, it messes up my grid. I like how the trace just completely gave up on its turn. Nice. Even though it didn't have to, it's like the radius settings are just not. I feel like curved traces were an afterthought on this program. They seem like they are. I like using them because I think they look good. All right, that's a little cleaner. Let me see here. Yeah, okay. And then the output will do a via and go over to there, but dude. Okay, what is next? What are next? I could center this a little bit better. I guess I'll just leave it alone for now, though. No, I didn't do anything like that. I just jumped directly into layout. Yeah, let's redo that. No, we're just jumping directly into layout and all of the information about what the size of the nets should be. I mean, this is digital circuitry. It's not even high speed. This is audio level, and it's 12 volts. So I'm not dealing with any of the things that like people love to worry about. Things like, is the trace wide enough, or is this signal going to have interference, or none of that's going to play into this because it's so slow and low voltage. We're dealing with positive and negative 12 volts. It's 24 volt max. Very little current running through everything. So 0.3, 0.4 trace widths and everything else kind of sorts itself out. What is C12 doing? C12. C number 12. Please show yourself. C12. 7, 13, 11, 14. I can search it. I know I can search it. You guys can search your hearts and try to find any humanity. C12 is on the key filter, or whatever it's called. Something or other key filter. So that is coming from the microcontroller through the TLO74 through 2. Yeah, that's the main output path. So the 2 filters are the output path, and that one was, I clicked on the wrong tab. Why are you on the left? You should be on the right. So we should swap these 2. Get swapped, fools. What am I doing? Modify? Gate swap? Nope, not you. Modify gate swap. Thanks, Mahalo. Yeah, everybody's been getting that auto thing. That's a long time ago, huh? All right, let's see what if that totally messed up my whole circuit. Yeah, it did mess things up a little bit. Wait a sec. Hold on. I'm going back to having it not swapped. We're going back to the original positions. So that's the unused one. Then I probably should have the unused one up here. This one's fine. Gate A is in the right place, but B and C, and then this one goes directly up to the other, the MCP whatever. If I do the whole triggery thingy, the whole output, well, this is the other part of the output right here. So I was using it on this side. We should move that down here because this one's just skipping out of town. It just goes straight over to the other one. So if I do this one, okay, so let's swap B and D, and that'll move 2 components over here, and then this will output on this side to go up to the microcontroller. Which ones did I want to swap again? It was B and D. Okay, and then I need to remove. I guess you can't unroute the whole thing anymore by clicking on it. And don't need that. This gone, this gone, this gone. Okay, so swap the 2. I thought it would be better to have them in a line, but that's not helping out. And then the CV here goes to a different chip. This one goes to this chip. So I could potentially swap. Let's swap B and D first before I confuse myself. Modify. gate swap, B, D. Ta-da! And then I have this is now going over to this side. It's 12 and 14 are part of the filter. 14 does just go to ground, huh? These two over here, I could pull them in, so that would be C and D swap. Man, that is like torture. The complexity of, it's not even that complicated. I'm just an idiot. D and C, there. Optimized. Optimized. Just give them a little room to breathe here. Although that circuit is so simple. Okay, so there's that. And C11, the decoupling capacitors there. R15, R17. I guess I could try to lay these out so that they look uniform. I haven't really been concentrating on that. Of course, the markings, I'm not paying any attention to the markings right now. That's a later step. Once you figure out where all your layout is supposed to go, then you can go and mess around with the markings. It shouldn't even have them in view right now. They should be completely censored. Sensors. Okay, let's see. So flip that one around, and then that is aligned. That one is going to both of those. And then our capacitor. Our capacitor is, of course, going to live on the other side of the board because it's huge. This giant electrolytic thing. But R16, I should be able to sneak a trace in here that'll pop to the other side of the board. And then this one, of course, will go up and around. Not even that far. I guess I can move it just a little bit in. Oh, it doesn't really matter right now. So, okay. Bop, 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 bop. Bop. That was a little bit off. That one goes to ground as well. What does this one do? This one is our output. I kind of want to move that in a little bit, though. Yeah. And I think my trace width is too big. Do it like that, and this one can go like that. I'm using the major grid to kind of lay these things out and keep them uniform, so things at least look nice. It's too big. 0.3. That little wiggle is going to look weird. Yeah, I guess it's okay. And this is the thing, everybody always does this. I'm not sure I'm a huge fan of it. And that would be nice if I got a little bit more of a bend. I could do a little squiggle. No, it's not. And squiggle's not gonna. Oh, actually, wait a minute. I could do a squiggle from up here. That's kind of sloppy, though. I don't like that, but I can do this and just make it uniform with the other one. There we go. It's the art of splitting hairs. All right, so then that goes up to the other one. So then this one down here, we've got a pretty decent amount of space. I'm probably going to end up looking at this design and thinking that I shouldn't have given myself all this space. Like that it would probably be fine if it was closer, all the parts were a little closer. But it's always like shocking to see the difference between your design in CAD and your design in the real world. It's nuts because everything is so much smaller than you expected it to be. Bonk, and then you. Oh, you're actually going all the way over here. Well, how am I going to lay that out? I would love it if it did not skip over layers, but there aren't many areas for me to exit. And if that were this gate, it probably would work out on one layer. So let's swap C and D and see what happens. Swapping C and D. Modify. Man, I'm glad for gate swap. That certainly saved us a lot of time. You don't appear to have switched. Did I not invoke a gate swap? I swear I did. Was it, oh, did I do? Yeah, I did the wrong gates. There we go. Oopsie daisy. Luckily we didn't do any permanent damage to the circuit. Well, it does seem confused. This one goes 2 places, but it's going to the other thing. So, all right, so this one, we want C and D swapped. And that's these two, not, ugh, jeez. So, each swap. There. And does that afford me a jump over, or all are the TLOs laid out in a different way? I think that, nope, I think that does it. I think that did the trick. I think it worked. Hold on, let's do this. I'm gonna line this up a little bit more. Bring this over here. Yeah, I'll just do it like that. Our negative power, of course, is coming in from there, but I should probably tell the software that that's a power trace, and I don't care about it yet, because we come back to those later. Oh, I don't like little bends. I do not like little bends like that. And I don't know if that is... See, it's hard to get all of my squiggles to align. That's a weird one, but I guess it works. Yeah, I don't like that. Don't like that. Again, like what I said before, these are decorative practically. As long as the copper gets there, it's fine. They're not carrying a lot of current, and the signals aren't going to be manipulated too heavily by my squiggly traces. So having weird stuff in your design in order to accommodate looks is appropriate in this case. We can't all be the Topor router, you know? One day I'll make a circuit and we'll try to use the Topor router on it, because I think it's hilarious how stupid those things look. The Topor routed, whatever they are, PCBs, where it basically does as the crow flies. It goes directly from thing to thing. But yeah, okay, so there's most of one piece of the circuit is laid out. I guess I can do the lines that go to the top layer here. The capacitor currently is in an open spot. Yeah, I'm gonna wait to do anything on the other layer. I'm gonna do is use the other layer as minimally as I can possibly use it, and then when I start tying stuff together, we'll do the lines that go to the other side of the board, because you never know, something else might come up that's gonna restrict your design. So our outs and ins are all right here. So we can actually run all of these up to the other set of filters. Dog is barking at a delivery, I guess. Okay, so U5, which capacitor does U5 get? Is it really called U? Yes, it is. Whereas this one has somehow made me switch over to IC. I think I corrected it on the other one, but U5, A and B. The capacitor is C15. Let's get C15 over towards where, I don't know which one, C4 I believe is the input power capacitor, so that one goes over here. C9 is our 10 volt one. C15 is that already in this bunch? Yeah, it's right here. Put that like this, just like the other one. And let's find a place for all of this equipment. So I was thinking that right here was the only good spot, but I could maybe, that doesn't really fit there. Yeah, this is really it for us right here. Which ones are coming from where? Looks like nobody is crossing except for that one is crossing. And that one goes to, oh, negative voltage. What? No, that one goes to here. That's the top one. And then the bottom one, bop, bop. Okay, so seemingly the only place this is going to fit, right there. Can I fit? Not really. Yeah, I wish I had a little bit more room around some of this stuff, but I don't like this being so close to the edge either. Seems a little too close. Also, that's going to limit my ability to run lines up and down the side. Oh, let me get this out of here. Is there any possible way that I can get it to fit down here? I would have to push this circuit down as far as I can, which means C14 and 12 would have to kind of scooch out of the way. Because I can kind of crush it down a little bit, and it'll give me a little bit less space. Be careful around C4, yes. Actually, C4 is so stable that you can heat up your coffee with it by lighting it on fire, because there's so many stabilization plastics in the explosive, and it was a frequent little bit of hazing that they would put people through, is lighting a cigarette with a little piece of C4. If I squish that down, am I really truly going to have room? Yeah, it's by design. It's super duper duper stable. Because that doesn't really seem to fit any way you cook it. Unless I really squish the circuit down, it pretty much has to go up here. Ah. There's no room to play. If I really squish that down, is that... Hold on a sec. I have to explore this possibility. It would be nice if I could have both op amps in the same spot, but we're talking like really restricting the amount of space that I have around stuff. I think I can make it work, though. Nah, I'd win. Because then there's room in the upper left-hand corner for stuff, and we get our gates real close to one another. Yeah, I think I'd win. So let's really sort of tamp this thing down and make as much room as we possibly can. Let's see here. If I can get these a little bit more out of the way, then that'll be to great advantage. So let's take this whole row. This is gonna, yeah, the little ends of traces that are left over inside of the pads that are hidden by the pads, they get in the way when you do stuff like this. Auto routers are huffing copium right now. So that's down there, and then this, move that out of the way. That can go this way. This one is just connected to ground from there, but I don't know. I would love to move it to either side, but I don't think there's too much space for me to operate here. Why aren't you moving? A little piece of trace on you? What is this? What is this? Hey, I need you to move. I hate it when it does this. That was why. That little piece right there. I feel like that's too close. I don't know. I guess it's all right. I see it. I see it. There it is. Those little ends are created by the very end of the run, like where it connects to the green X that it creates. It can't like move that little tiny end, but it creates that little end in order to get that last little bit of distance in order to complete the air wire. Oh yeah, this is moving this stuff too. Damn it. I tried to spread out initially in order to give myself room to work. Cursed. Every one of my intentions blows up in my face. You got to do this sometimes, is just start over. And really what we're trying to do is get all of the op amps in one part of the circuit. It's going to make things a little bit more difficult for me, but it's still manageable. Make it all manageable. Let's see. There, and then we're going to take this and we're going to pack it in. That's going to go right. That's too close. that's not too close enough, but I think we'll deal with it there. And then R15 down this way, try to avoid the other part of the circuit. I guess I can do it like this. I don't know. Because this part needs to skip over to U5. U5 is going to be kind of crammed in, isn't it? Oh, that's a lot of support equipment. That's a lot of stuff. Can that go? Well, let's see, the other one doesn't have a lot of stuff. It has very few things. This thing has many things, so I think I'm swapping those two. And then these parts can go in the jumble with these parts. So let's gate swap the MCP. Gate swap the MCP. Yeah, one of them is just like a very simple layout, and the other one has all this crap associated with it. So modify, gate swap, you, and you. Okay, so now we got our few thing down here. What are you going to use the modular synth for? I'm going to use it in order to farm grapes. I don't know, what do you do with modular synth? You make sounds. I'm going to make cool sounds out of it. What are you going to do with your modular synth? Yeah, modular synths are something that I've not had a lot of experience with, but I'm going to try to see if I can make music on its own, basically, which is sort of a tenet of modular synthesis. And if it makes music on its own, then I have uncopyrighted music on my stream, and I don't have to worry about all the damn copyright stuff that I constantly worry about. This is better if it's over here, isn't it? And these two are in parallel. Let's move this. How can I get those in parallel and still have this part of the circuit function properly? Because this is coming from over there. What is going on with this? This is just like an input to there. I don't really want to move this any closer because I got these two pads right here, and this has this whole block of stuff still needs to attach to this one. So that'll probably break out into the, maybe above that, but I don't have room for, I don't think I have room for 2 rows unless well, if I did this horizontally, which is sort of a last ditch effort, now I have room for everything. So I guess that's how it's got to be. That's how it's got to be. Oh, which means I'm swapping the gates back again. Okay, fine. Have it your way. Whatever. See if I care. Gate swap. Piece of crap. Gate swap. Can't believe gate swap. I wanted to keep them sort of oriented in the same way, but it just doesn't work. PCB way. I'm going to use Seed Studio. I know their process, and they've done good by me in the past. A lot of people have said PCB way today. Boy, would this make more sense if this was also up and down instead of right and left? I think the answer may shock you, and it's yes. I think the answer is yes. So if I do that, and they're all then facing the same directions again, and I get to preserve my sense of order. But that means that I probably will want to swap. Yeah, I'm gonna have to swap gates all over the place again. Okay, well, it's fine. You win this time. Gate swap. And these I'm gonna sort of vaguely put in this area. Yeah, that using the side to side actually helps me quite a bit. So R15 and 17 are still associated with this output. R14 and etc. Okay, so now we can take this whole thing. No, I guess not. Just unroute the damn thing. Just do it. We don't get that double click functionality anymore, do we? Oh, there's still stuff. They always leave a little thing behind, huh? Okay, so center that in the location so that I have room for stuff on either side. And this is the decoupling capacitor, so a good spot for that is somewhere just above. This is our input. If I do this, I can do this in line like this. Bring this one over here, and then that will be gate A, which was formerly gate D. I'll do this one at a time so I don't confuse myself. So A and D are swap. D and A. That's funny. A has a lot of connections. Why did it look like it was only 2? Because we're coming from the microcontroller and we're going into the... Oh, whatever. Okay. Why is that wrong? What did I just mess up? What did I just mess up? I think I swapped something bad? No. All right. Come from the microcontroller, and we're going into the analog output, which is now, since it's crammed down in this corner, that requires 2 circuits. If I make it these 2, comes from above, goes to these 2, or I can make, because this one goes to the MCP immediately, this one stops off over here and then goes to the MCP. So that would be, that one's gate B, or sorry, that one's gate C. If I flip gate C, then the MCP is right here with the smaller part of the circuit, unless I do these over here, which is probably better for them. And then the unused gate is where? I think that's, oh, that's this one, okay. So we can swap the unused gate with, where does, hold on. Like this one goes over there. Oh man, this is hurting my brain. My brain meat is starting to sizzle a little bit. I don't think it would be a good idea to put these like, it would look better if I did them like this, but I don't know if that would be a good idea unless I take advantage of the unused gate there and I put them in line with one another very close together. But they both need some components between them, so I'll see if I can do it. Just to make it look good. I mean, that's what most of these decisions are coming from, is what looks good. But yeah, coming out of that gate and going in 50 different directions is a little weird. What are you doing over there, C14? Which one is C14? That one was the... It's 12 and 13 that are doing that. 14 was that... That wasn't a decoupler. No. Just a couple degrees. I don't know if this program can do that. I don't know if I can do that in here. Oh, I hate it. Oh, I hate it. Oh, I hate it. Oh, I really hate it. It is so tempting for me to use that, though. Just have it just at an arbitrary angle, just to be stupid. I mean, if I open up that Pandora's box of fuckery, then I am never closing it again. So I am not going to do that. I'm not going to do it. It's too messed up. My poor little heart can't take it. The capacitor that decouples this one is, well, U5, C11's text size is wrong. Anyway, which one am I looking at right now? C11 is the decoupler for positive and negative power. The one for the other chip, that's the wrong tab. This is where having multiple tabs open on multiple monitors is really useful. Because I'm streaming it, I'm limited to one singular display of everything. But if I were not streaming this, then I would absolutely have the schematic up on a different tab. That way all of this flipping back and forth would be minimized. I just have to glance over at the other screen to see what's going on. So C11 is for the TL074. C15 is the one that I'm looking for right now. C15, I thought it was in this stack. Everything is chaos right now, just because, there it is. Everything is chaos right now because of the flipping of the stuff. But I'm trying to make it pretty right now. And minimize the amount of air wires between things. So that wants to go there, but it would be probably more prudent. Although having everything exit the top and the bottom of the chip is bad too. Although I can put this over here. We just have to avoid those pads. So if I make, which one is this going to? That one's D. D and B are being swappied. We are not done swapping gates, that's for sure. Oh, A is the one that's unused. I want B. But if I swap B with A, B can go to, I don't know, let's just swap A and B and take a look at what we got. So now, did I actually swap the right thing or did I click on the wrong thing again? I swapped A and B. Wait. What? No. A and B swapped. Yeah. Yeah. So this should change. Okay, I'm looking at the wrong. Oh yeah, I did A and B, not A and, okay. So the unused amp should probably end up here, although the audio path should go through this side, but then it would diagonally cross. Oh man, I'm confusing myself right now. I'm trying to get all this stuff straight. If I do the audio path on the right side of the chip, then all that equipment goes to the right in that nice big open space, and then the other TL074, which is used for, what is it doing? It's doing the mix, isn't it? Because that's the new stuff, and those both use the MCP. And if I keep the right side associated with the MCPs, then this part of the circuit, which is an input, a capacitor, and 2 resistors, and R8 can go over towards the MCP. And all this stuff will be on one side of the chip. Of course, that layout is pretty cursed, but that would make C and D this side, and it should hit D first. So I need to gate swap these, and then I need to gate swap with C, because it'll go from D at the top of the chip to C at the bottom of the chip. What happened here? Oh, that's right. The end of the part number is D. My brain is trying to kill me. Gate swap. And then I want A up here. Let's see. A and B, between them, I guess I want B to be the one that I'm using because it's a little closer. And so A will be the unused op amp, and it'll be up in the left corner by the MCP 6004. How does that work? Let's see. C7 is just an ESD protection. And then unroute this, just so we're nice and clean. These components come over here. Nice and out of the way. Of course, the hard part is going to be connecting around these ground pins. I guess I could just put it like this, and then I'll just have to route a couple more traces. Everybody's off grid. What do you hold to put it back on grid? It's probably using an English-sized grid too, so it's, I don't know. I'll just get them to kind of be in nice places. Nice places, not mean places. Where do you go? You go all the way over there. That's gonna have to take a trip to get there. And then this side of the thing coming down from above, but then that goes over here. That's also gonna be kind of awkward. I feel like I've swapped the sides where I want them the other way around. But this is where we have all the room over here for all this stuff. What are you? C12? Between, huh. That's an odd one. How much of this stuff can I move out? I guess we'll have to take a look at that next. Because yeah, this comes down from above. Mixes up with all that stuff. Man, this is complicated. I don't know why I'm struggling with this today. You know, when I do this stuff on my own, it's just wham bam, everything's perfect and easy. One after the other. All this stuff moves over here now. We got this huge blank area beneath it. Thanks, Dither. I guess that's the thing Twitch does now, is it notifies people of my partner anniversary. It's weird. Can I turn it off? I don't know. I don't know. Yeah, that's totally doable. Here, check it out. Hold on. Where's my research window? Yoink. So Topor. There were some boards that we were looking at a while ago that did literally that. They just threw all the components down at random rotations. But Topor routing is wonderful for those because it literally just does it as the crow flies as possible. I forget what the other board was called. I think it might have been a modular synthesizer thing or just a synthesizer thing in general, but it did just look like the parts had been thrown onto the table and then routed directly in where they need to go. I am losing sight of where these circuits are located and how they're supposed to be laid out. I think what I can do, what I sort of want to do, is pull this off to the side where I can think and minimally position everybody where they're supposed to go. And that might help me figure out what the shape should be. Just, you know, rid myself of the shackles of the circuit board and then figure out what that's going to look like in the end. Because I'm having trouble visualizing it and figuring out where the circuit elements are really supposed to be sitting in relation to one another. So I'm going to pull everything out and then I'm going to put it back together based on how the schematic treats it from chip to chip, and then we'll roll from there. I'll keep these capacitors out in the way. That's just the label. Okay, so I wish I could unview some of the other ones, but let's see about what we can do here. So if we've got our MCP 6004, looks like an electrical engineering nightmare. Glad I became a computer operator, not an IC designer. I did not have this trouble with the other board. I don't know why. This board did not give me any trouble like that. I was having a great time laying out all the traces for it. Maybe just because I don't know, the circuit is a little bit more easy to squish stuff into. There's very little kind of going on here, and I was able to just kind of get this together and get it all laid out and logically sorted. I mean, this is pretty clean. It's not too messy in here. But for some reason, I'm struggling with doing this with the other one. So I don't know. We're gonna keep moving though. I mean, that's, you know, our momentum is very important. As long as I keep going, keep making stuff. So we're gonna start with something. I don't even know. Let's start with, I mean, the audio output path involves TL074s, but I think what we're going to do, let me take a look at the input first, I suppose, and we're going with P26, C6, R6, R3, R9. R3, R9, C6, R12. I'm going to open this up in a different window, so you guys will see me referencing this, but you won't be able to like see it. So I'll put that over here, this monitor. I don't know, that might be limited to, the free license might not allow you to do this. But thank you for the partner anniversary wishes. I appreciate that very much. This is very complicated stuff. All right, so now I can see the schematic and I can still see chat. I can't see OBS, so I don't know if I look horrible or not. Don't answer that. Okay, so we've got our, see, we're doing the meat of the circuit. I'm doing all this stuff down here. All the op-amp stuff I want to lay out and get it sort of in good spots. 12? What's 12? Surely not my partner anniversary. So MCP 6002, there's an A and a B circuit. It's my favorite Monty Python audio tape joke is the party game. Let's play a party game. So split the room into the A team and the B team, and the B team are the winners. All right, so this, we have the two there doing their op-ampy stuff. I could scooch that up like that, maybe. I kind of want these, what do you hit to put them back on the grid? More beard balm. If I use the brush on my beard, it kind of tamps everything down, but I need to cut. What about my normal design process even begins to give you the impression that I would do any kind of simulation on this at all whatsoever? That's the only thing the MCP 6002 is doing. Goes up to, where's R8? R8, what are you doing, R8? See, it's going through R9, which is next to the chip. R8 is between two completely different, oh, I see. So that one's coming up from the other, that's the little, and actually that is the smaller one, so it's better that it is on this side, although it is associated with the other input that uses a TL074. But then by twisting this thing, I've made this huge pocket of open space on the right of that. So if we swap the two, I guess then I can't take advantage of this area, but I can take advantage of this area for all the other components. I've had to explain myself on the simulation thing so many times. I don't know what you guys think I could gain from simulating. Oh wait, it's over here. So I can just swap them again. I forget that this is actually a CAD program over here. All right, so let's swap. Now all this stuff goes over on this side. Yeah, I don't know what I would gain from simulation. Yeah, see, that's working out better with the other circuit. Those two are in parallel. And then they go through R9, but R9 takes us to the, where's R8 going? R8 goes to, R3 goes to our power, our -10 power. That's C13, the label just moved quite a bit. R17, I must have missed that one. Yeah, C6, C7, C5, those are the ESD protection capacitors. And then R9, it's all the way over here. What are you doing over there? You go to this. So R9 can probably hang out around here if I have space. Like current limiting the input signal or something. And the next stop for R9 is... why is it over there? Why must you continue to disappoint me? R6, C6, R3. That's all that circuit is. The other one has... the other one's just as simple, actually. There's very little stuff that has to be around this. So yeah, this can squeeze in pretty heavily, actually, if it needs to. So I can put this, I guess, that. This one should mirror it exactly because it's the same circuit. These are just MCP 6004 input circuits. I guess it's a good op amp to have on your synthesizer's input because it's limiting, it's only has access to 3 volts, so it can't blow everything up. Where's the output of these? It's up there, and putting this any other way, yeah. Well, if I really need to squish it in, I guess I can move the resistor out here and have it do it like that. Of course, that, well, that actually takes advantage of that area perfectly. Okay, so yeah, these are the steps that are leading to the other chip. We're going to make that fit in here. I think I can do it. I'm not actually as limited on this side either. I'm probably going to be really annoyed with myself when it comes to soldering these things, though, because I do need to have some traces that go to other stuff, but okay, so one of these is the unused amp. The other one, that would be this one here, is not used. And so the unused circuit, or the other circuit, goes between the MCP and the pin. It might be better for me to move it up so that this is the unused one. That'll get crammed right up against these pins right here. So swapping A and which one is it going to be? A and B. Yeah. Okay, so modify. Gate swap. A and B. There we go. Okay, so A and B are swapped. Now all this stuff can go up here with its buddy. These are kind of tricky. I don't know what to do with that. That goes down to the pin. So if I can fit that, and the problem is these 2 connections are going to be kind of annoying. And that'll probably want to be right on top of the... yeah. It's like kind of can cram it in there. If I move stuff out a little bit. The whole corner just gets neglected, doesn't it? Yeah, so this will be tricky to route, but I can still do it. These can move down a little bit. There. And then from the MCP, that one was, oh, I'm clicking the wrong part of the window. All right, where are we? Show the audio output circuit right here is what we now need to do. So I need to come from P2, which is up at the chip, and we'll piece this all together bit by bit, part by part. So the first thing I'm going through is R12. R12, keep it on the outside probably, although, yeah, R12, this is going into the key filter, whatever it's called. R11, C14 ground. R11 is not here, unless this is it. It is. Yoink. Let's get that label back over. So the resistor and the capacitor go directly to ground. Where are we getting... oh yeah, that's right. This is coming from outside. So there, there. And then C14 goes to ground. So I can do it like this, maybe? Well, it's getting a little close, but... which one of you is off? It seems like none of them are off, and yet everything is colliding. I didn't make these parts, these resistors and capacitors, so they're a little bit weird. They're a little wonky. The pads can be a little restrictive. Just the labels would get out of the way, though. I guess I can hide them. Well, I need the labels every now and then, so I'll keep them for now. They're there, and then we're going down to there. So I guess I need to flip this. What is that going to look like? Unless this goes down here. Well, C13 needs to be there. And then C12 is which one? C13, C12 is the I don't know what it's called in this particular circuit. This is a weird circuit. This is a tough one. I guess I can do this here, and then this can switch like that, or like that, or like that, or like that, or like that. Maybe like that. So far, so good. We're piecing it together, trying to get the air wires to not collide with one another. I'm trying to keep them in a direct route into the chip. I think that's that circuit. And then it goes over to, it comes from the knob, from R20. R20, yeah, right there. Okay, that's gonna, you know, do a whole journey on its way in and out. So that would be our adjustment part of the circuit. Wait, why is the adjustment part of the circuit there? If our output uses those two. Okay. I guess this is our audio output over here. So this leaves what part of the circuit? This would be R18. So we're talking about, that's this. Oh, this is the last portion of the audio output circuit right here. So R18 and C13. So we were just coming from the C12, etc. loop there. Because the first part of that is a low-pass filter to get rid of like really low tones that the A to D converter will accidentally create. And then the second part of it is about boosting it up to analog synthesizer levels. That feedback, the R18, R14 relation, I forget what it does. I was told once, I read it in a forum. I think it's a way of filtering at least C13 is a way of filtering out high frequency noises. When you get to the high frequencies, C13 starts to act stronger on the circuit and causes it to tamp down those frequencies. But I don't know precisely what that design does. It's Mutable Instruments came up with it, and I'm going with it because I know it's good because it's Mutable Instruments coming up with it. What about R14 precisely? Put it there, and then R16 goes between, that goes to the cap and then to the other side of the circuit. So that one can go many different places if it needs to. Or I can put it on the outside over here, but that would mean I need to push C13 down, and I don't think it's going to like that very much. You go between those two, so I could potentially flip that on its side, but then C14 is not going to take that too kindly. Just do like that. Modular suppressor type thing, compression as well. Interesting. Yeah, I want to read about that again because I forget. I do not remember. All right, that's looking a little better. The potential for more gate swapping still exists. It'd be nice to have all this room, but I don't know if I do. So let's put this back in and see if I've done good. Let me get the C's away from the pins first. I'll make a little room, and then we'll see where it fits in the form that it's in and whether or not we need to move a thing or two. Of course, the CAD program is going to fight me as well on doing this. This is not like a sanctioned way of doing this in the CAD program. So if it bumps into stuff, it's going to be like, oh, you can't do that. Moving these in a little bit would be good too. How would one accomplish such a feat? Well, this thing doesn't really have a lot of room to operate, so we'll see where it likes to put us. Let me get this back in and close, and we'll see if this weird looking thing will fit over here. Very close to fitting. It's just if I'm going to bump those parts out, I might as well bump them all the way out and make this a little bit more centered just for visual purposes. So I'll take these and move them out, and we'll get the rest of this. I moved them in a weird way. Why don't you guys just sit over here right now? You take your labels. Oh, these are labels for me so that I know what this stuff does. I put labels on the front and the back of the PCB in order to tell me what pins went to what, because I figure these circuit boards will be a good general purpose synthesizer module circuit, because you can make that RP2040 do whatever you want. And I think, I'm not totally certain, these can receive audio and be a filter. Might as well put R9 here. Although I'm probably going to need things to be a little different. Like cutting the bottom of this is probably not good practice, so maybe I'll take R9 and put it a little more local. I don't want it to stick out the edge of the board, though. Thanks, Pyro. The heck is this? I know, they're like, you will have your partner anniversary. It will be announced. You have no choice. This is not a question. All right, slowly but surely figuring out this layout. Where is C5? Where's C5? Hello? One of y'all. Oh, that is this one. Okay. All right. Oh, it's getting cold in here, actually. All right, good enough, good enough. Labels we'll do later. I'm just trying to keep track of them and keep them from interfering too much. What are you going in between? So you go to the capacitor over there. There's plenty of room over here for me to put another row if I need to, but I could get away with putting it here too. But all this is going to do is bump up to the other layer and then go to this. Like there. 5 years subbed? That's 60 months? Holy shit. Yeah, well, time flies. That's a lot of months, man. Thank you for all the subs, Pyro. Thank you, thank you. Let's see, both of those have to connect to pins. This can sneak up and away, as it only has to do that. These are kind of going to be tough to navigate. And then C7 is protection, so it should be in this area. Well, it probably should be the first stop. I don't know if I can swing that and just put it there in between them. I guess that works. But then that jumps up over to this layer, and these have plenty of room to play. Yeah, I won't get too close to the chip with that. Let's just align them a little bit. I'll probably curse myself for putting things so close to these, close together, the chips and stuff. Can I get R3 to go anywhere else? Yeah, I can. I can, actually. What is that connection? Oh, that's -10. I see. I see. Well, R3 shouldn't go too far away then. R3 should stay associated with this area, which means if I can just scooch these up just a teensy little bit We'll give R3 a little space right there. I gotta close the window, I'm freezing. What temperature is it down here? 69.5 degrees. Oh my God. I thought it'd be further along with this design by now, but it's getting everything to fit right and look right and be perfect is kind of tough. But we're utilizing a lot more of the circuit board now. And keeping things from getting too crowded. I need to not view anything on the top layer though. Preset standard. See, that views everything now. Now we're looking through the board from beneath and seeing where all the equipment lies on the other side. But I don't need any of this stuff because it's all in the way. What are you doing? This is from negative. So this one is a power. Ground is not represented in the air wires. I told it to hide ground. The ground air wires, that is. So it makes things a little bit more simple. So like this would have been, you know, rife with all these connections, but it's nice and simple and easy this way. It's coming from negative. Okay, so let's view only the bottom layer and then start managing some of these air wires, start eliminating some air wires and getting our layout down on the page. I could move this whole row out to make room, but I don't know if I need to. This is not going to play well right here. These parts have like a keep out area that's in most of the layers. So I need to figure out a way to dance around that. Let's see if we can do this first, I guess. Yeah, see, there's nowhere for me to go. I've painted myself into worse corners. If I swap them, then I can kind of sneak them out down. I don't think that'll work. Yeah. Traces need space. Need space to breathe. Wow, it really gets creative when you limit it like that. Okay, let's see. So, this is kind of a tough one, isn't it? And I could move it to the right a little bit. This isn't going to play well. This would be okay moving. But then these two traces these are immediately a huge problem. Just because this part keeps me from routing around it. And C7 is, of course, blocking my way. Move that down, move this over. I can't minimize distance to the edge, but that's gonna, yeah, see that keep away area? That shouldn't be on the bottom layer, but I guess they want to keep that free. I guess it probably also gets into like board edge territory too. You don't want your traces to be damaged by the drill. I'm just trying to think of how I can get traces out of here. These parts are a lot less workable than I thought. They do not play nice. Of course, this can go out and around. I can go out and around the whole thing. If I've got room for one to go up here and another down here, that might be enough. What is this thing doing? This is just amplifying. I can potentially get both of them from down here too. Although one is the output line, so it'd be this one I would need to get out. This one can get out that way, but then it would have to cross this one. Maybe that's the way to do it. All right, let me swap the two gates and we'll put it down here. I think that's the best way to go. So it's A and B, and I've got it in a different window. So I'm going over to my modify, H swap, and that's A and B, this one, and this one. It's funny, it highlights it as you click in the other window. All right, so now we're coming from down here. Got slightly better situation. Push that further down. No. I just need the room for the one trace in front of this thing, and that's going to set all of my... Everything's going to be lopsided now. I have to do like a big select of everybody. Okay, all right, what are we doing? Get out of that tool. Everyone here, need you to bump. Yeah. It's a fancy asymmetrical offset that'll make it look cool. Let's see, if I do this like this, I don't think I can fit two abreast in here. Nah. That just makes it worse. My kingdom for some topor routing. Utterly cursed routing scheme that it is. Do it like this, that, like this. That one kind of doesn't really matter how it's laid out. All right, so now I've got room for better or for worse. I don't like to do this, but I guess if I have to, I'll do that. I don't like that though. It's weird. All right, so is this in a logical place? Not really. Why is it bumped out in a weird way? There we go. Nice and boring. Huh? Oh. Oh, I see. It's supposed to come from over there. Whoops. Whoopsie daisy. Well, C7 should be a little closer to this anyway. Make it line up over there. There we go. Okay, so now that's going to look like this. Good enough. Should I bump it out like that? I'll try it. I'll try it and I'll see if I hate it. Oh, it's supposed to go over here. There. Try it and see if I hate it. I want the first stop from the plug to be that ESD capacitor, because it's not just a capacitor, it's like an electrostatic discharge device. So on a dry day, I don't blow up my RP2040 or my op amps even by shocking them to death. So this signal here has to go up here. So yeah, I am gonna hate that trace. Control Z, go away. I never want to see you again. So instead, I'll just go the more direct path. The more direct, okay, there's not a more direct, but there is a little bit of a more direct path. So I'm going to scooch these both inwards just a little bit. That was not just a little bit. Kids, scooching, make with the scooching, kids. Okay, just like that. And then get rid of this, and this, and this. And then I have to come in from up here. Although I could flip the resistor, and then this would be a weird squiggle path. I think I'm optimizing a little too much here. I'll do it. I'll do it anyway. You can't stop me. All right, so from here, like that, and like that. And then we take it from here. That's too close. Go to there. And then from here, go all the way down. Ah, what are you doing? It's like super optimizing things because of my grid spacing. Because of my grid. What have you done to my grid? Did that probably, sometimes when you drag traces, it ruins them. There we go. That's a little weird. Now, weird is weird. Weird and works is fine, as long as it works. Okay, so from there, we're doing another weird squiggle. What is going on? Okay. That one to there. This one to here. Same thing over here. I don't like that. I don't like that either. That's kind of, well, I have to live with it. I have no choice. All right. Same thing on this side, except this one has slightly squigglier things. That's kind of odd. I don't think I like that. There's probably a better way to do it. There's probably a way that I can, like, make the squiggle look okay. That doesn't look right. I feel like I've done it before on other boards. Ugh. Ugh. Ah, anyway, I look at this, I lose. That's hideous. I hate that. I really dislike that. Can't really move it down because the grid is kind of messing with me here. If I move it up, I could do a double swoosh, but that would be kind of weird. If I keep the trace out here, I could do a weird junction between them, but I don't like doing those three-way junctions. That's got to go all the way down there? What the heck? Oops, keep that like that. Oh yeah, it should be the capacitor first. I just got finished talking about that. You just said, and then you didn't do it. Why would you lie to us? Okay, so like this one's coming up and over, like this, and this one. I'm gonna go from here to undisclosed location, and then it can come down like that, and it'll make its own turn, and then these are not even with each other. Oh God. What have I done? Are they actually even? No, they're not. One of them is spaced based on the pin. Yeah, that's why. There it is. What do you hit to put it back on the grid? Not that button, that's for sure. All right, so I'll just redraw it. Doot and doot, and then we'll take this guy and take it up from there, like this. And then I just need to go straight across like that, and it should have, and didn't, make a nice little Y junction. But instead I got this hideous monstrosity. Take it from the spot that I know is good here. On, oh man, come on. It's making an embarrassment out of me. That does that little thing at the end so that this can then look perfect. It's annoying to do, but they look good. Bonk. Okay. Now I could probably use a little help, but I guess it's okay. Kind of annoying. All right. Next. I still don't like this area. This area is still annoying me. Oh, I see. All of you are connected together. What are we going to do about that? I mean, the curve in there isn't really doing its job. It kind of looks stupid, but I guess I have to keep stupid. Yeah, I guess I got to keep stupid. Unless I move them up a little bit. That might actually work. Move everybody up. Okay, en route. Goodbye, goodbye. Take you. Bump. Too far. Put it like there. now I've got a little bit of freedom. Like, thing is, like, the -10 is coming from over there. I need room for a via in this area for the -10. That's the only way that I can really pull that one off. Something like that. And then if I do straight over, it's going to be weird. Well, straight over it is. I guess. I don't like it, but it's not there for me to like. If I really wanted to make it super fancy and take up a lot of room, then I would do those Y splits to everything. So you'd have the line coming out, and then I would do the Y split over to the thing. It would look much better than this. It would make more sense. Thank you, Dat Dolphin. How you been, Dat Dolphin? It's been a while. All right, so from there, we're just connecting all of the little stuff together to try to clean up all the air wires that are everywhere. And with fewer air wires, we can then take a look at a different part of the puzzle and get that all sorted out. Wait, huh? Oh, that goes to the part that's on the other layer. That's a part that's sitting above us. So I guess we could just do it that way, and then I'll take more routing from there to there, there to there, and then that one goes to another layer, this one goes here, and so we're starting to clean up some of the spider webs that we had in that area. How in the hell am I supposed to... What you've expected from me is too much. Let's see. So if I come from down here and I go this way, then it gets all mangled by all the stuff around it. Try to line that up. I guess that's okay. I guess that's okay. It's just going to look a little funky. Down to there, and then I take from here. Nope. Always trying to reroute stuff. Always trying to ice skate uphill. There we go. Just like that. Like watching paint dry. You fuck yourself. How's it going, Lost Miles? Why are people showing up out of nowhere? I don't understand. I got a lot of names that I haven't seen in years. Oh, Lost Miles. Last Miles. How's it going? Sorry. My notifications are on another monitor. I'm looking over here. Rating with a party of 95. Oh my God. That's why. All these names that I haven't seen for years, I'm like, what is going on? Did somebody like do something strange? Yeah, so we're putting together all the traces on a modular synthesizer. I'm back at it, the modular synthesizer thing. Jeez, I deserved the fuck you. Hey, you know, I'm gonna clap back. We're doing this in Fusion 360, which is a program that I've learned to like. It's got EagleCAD written in with it. So what's happened is I have started with, well, actually I started with the front panel, but I started with a design, basically a napkin design out of two different alternate synthesizers. Yeah, I didn't even know the raid happened because the notifications are on a third monitor. I had to get another monitor. What a welcome. Whatever. I'm gonna clap back. Anyway, so yeah, this CAD program contains the schematics, and the schematics are there in order to tell the CAD program what connections need to be made, and so it assigns values for all the connections. I don't put values into the schematic. I can actually put values in here and do like a simulation of the circuit, but I'm not going to do that. I don't usually work with it like that. The reason that we're doing this is because perforated prototyping boards are completely and utterly obsolete. You don't need to like do these anymore unless you've got like a quick fix that you need to do or something like that. Like you can buy a circuit board for just anything. You can just buy one to do whatever. You should hit refresh on your end and see if it's still out of sync, because anyway, so this is going to be a chord
voltage controlled oscillator. Instead of just one sound, 3 sounds will come out of it. Its design is very similar to the regular voltage controlled oscillator that uses this little RP2040 microcontroller. RP2040 microcontroller, it's like $5, and you get USB-C, you get a couple LEDs, and all this stuff works really, really, really nice. Voltage controlled oscillator, it's oscillating in audio frequencies from the microcontroller, and we put it through a little low pass filter, and then we cut the DC component out, and then we put it into synthesizer voltages, which is what these different circuit things are doing. Modular synthesizers run on plus minus 10 volts sometimes, and so we're in sort of analog space where ground is sitting in between a positive and negative 12 volts. So anyway, I've put all that stuff, all those concepts on paper, and I based them on designs from both Hajiwo, whose window I've lost. The window is lost to time. Where the hell did it go? Hajiwo, who is a YouTuber that makes cheap modular synthesizer stuff. So like you see right there, $4 Sparkle patch cable. He's got $9 Raspberry Pi VCO, $23 module. So like modular synthesizers are a way to extract money from musicians. Hey, Kung Pao Jeff, thank you for the bits. Yeah, it was a big raid. I didn't even know it happened. Sorry. I thought people were showing up out of the woodwork and just berating me on stuff, but it makes sense now. Anyway, so yeah, the whole point of this thing is it's not terribly expensive. And so I started to actually build Hajiwo's circuit on perforated prototyping board. I didn't like it. I got mad. And so with a little bit of extra work, we can use Fusion 360 to put the schematic that I came up with, build it, have a circuit board made, and get 10 boards for $5. So this is a fun thing that I can do in order to have a lot of very capable digital synthesizer modules. It's not analog circuitry. I mean, this is all the amplifying up and down is analog, but having that sort of like digital circuit board ready to go. So yeah, well, I'm not sure. It's going to be like $25, $30 for me to do the 10 circuit boards. So I'm out $60 for the circuit boards from Seed Studio. Shipping is the nightmare. Shipping from China. We're skipping the step. We're skipping the step of perforated, building it on a perforated prototyping board. Yeah, all those Futurama schematics, typically they're guitar amplifiers when they show like the robot pornography. The Adventure Time schematic was specifically of a vacuum tube amplifier, but the Futurama one is a little bit more, it's just electronics gobbledygook. Like they're making up symbols and stuff for it too. But when you see a competent schematic in cartoons, oftentimes it'll be like musical equipment. So once I've programmed what all the chips are, and I've made sure that all of these components have proper footprints, and they're the same kind of technology that I'm using, like surface mount versus through-hole, what you do is you jump over to your board layout, and that's what we're looking at here. We're kind of in a hardcore board layout situation. Part of the board layout is making sure that things like buttons and switches are in the right places. And once you get all those buttons and switches in place, then you are limited in the positioning of your support components. They can go anywhere, but if I'm to keep this circuit clean so that I can look at it and know what is where, I need to make sure that these little air wires are not overlapping in ways that violate sort of the principles of what I'm designing. And when I'm done that, I can then do a 3D render of the circuit board. And so here is the one that I've already completed. It's similar to this one, but that is all laid out in 3D. And so I've got the RP2040, the exact model of it from Seed Studio. This is the RP2040 Zio, I've been calling it. And I've sort of made my own three-dimensional part. So as I move that around on the board, the 3D model will also reflect those changes, and I can see if stuff actually is conflicting or not. One of the big conflictions is the pads needing to be bent in order to fit in. But that's what we've been doing today, for those of you that don't know. And are polite. So it may look like it's watching paint dry, but the payoff in the end is actually really cool. I designed the front panel first because I thought I was going to be doing the perforated prototyping board, and I had a little heart-to-heart with myself saying, listen, I can get 10 of these boards and then I can like basically throw them at my friends when they come over to do music. So I've decided that I would do the circuit board and do it first and skip the entire prototyping step. One thing that I do need to do is measure these pins to make sure that they'll fit, because I think the 3D model that I got for the switches is just a little bit different than the actual thing. Just a little bit different. But yeah, it's kind of incredible to be able to see the board in 3D like this. Usually this would be the end of the story until I actually am able to order the board. Now right now we're looking at the bottom layer. Bottom layer is blue, top layer is red. And there are parts that are on the top layer that haven't been put into place yet. What the way that I typically strategize this is what you just saw. It's basically put together a circuit that you think is going to work perfectly, test it, which we didn't do, and then you build the circuit. You either build the circuit on a perforated prototyping board or on a solderless breadboard. The best place to go is the solderless breadboard now. So you do the solderless breadboard and you put it all together and you figure out if it works. Then you go and do what I'm doing, which is lay out all of the hardware, all the fixed positionings on your board, then drill down to the more complicated parts of the circuit and make sure that everybody has room to breathe. For the sake of clarity, I often call my streams Watch Paint Dry, and thus it was a group joke. Ah, yes, I had no context on that. I'm not, don't worry about it. I'm not mad. I get comments like that all the time. I just clap back at them. Everybody here should check out Last Miles, by the way. Last Miles is a very good streamer. SO Last Miles. Is that going to work? Oh, wait, I don't have that command. /shout out username Last Miles. There it is. That's the official one. I guess Nightbot caught it too, so I didn't do anything wrong. Cool. Yeah, so the Mutables Instruments, very interesting circuits in there. Amelia, I think it is, released all of her stuff, all the stuff, all the schematics and the board layouts. So I was able to take parts from Mutable Instruments, and put it all into this stuff. I also have my own parts library that I had to bulk up in order to get all of the specific parts. But the thing about the Mutables Instruments designs is they are designed to take in and send out the proper voltages. And so we're copying that part of the circuit. Then we're taking Hajiwo's, other elements of Hajiwo's design, and we're kind of shoving it all together in this board that I'm creating. So I have to give plenty of credit where credit is due in order to make this. And I guess I'm not selling it. If anybody wants to repeat the design, they can go to GitHub, and they'll have to pressure me into actually putting this on GitHub, because I'll do it. I'll freely list it. Some of the first computer software was designing other computer chips. The totem pole of sort of tagged, like the totem pole of technology that even just like programming a microcontroller involves is very interesting to me. In automotive stuff, basically you have this old system that you need a more advanced system to observe, and then it gets more and more advanced, and so all of the vulnerabilities all the way down the line permeate the entire system, to the degree where security researchers are doing things like reprogramming modules to reprogram other modules in that line. They can get to the sort of high priority systems by taking advantage of that sort of stack of technology. I'm going to take this one and go under the chip. I hate going under the chip. I think it's bad practice, but sometimes you got to do it. And I want to leave plenty of room around here because this pin right here is going to need ground. And so it'll get it via a via, which is just a hole in the board. This, I don't like that at all. I don't like how that looks. I don't like it. I don't want to participate. Okay, let's see. So like that, I'm being a little quieter because there's people in the house right now. Usually I try to be loud and emphatic and, fun, actually fun. But yeah, I gotta be quiet. software is very interesting like that. So much stuff is built on top of the previous things. Yeah, you take it in as like blocks in software, right? And you don't... very, very few times I've seen software projects giving credit to the building blocks that make it up. If I were to make money off of this design, I would feel very bad if I had taken lots of, functional blocks from other people and not giving them credit. You get in big trouble for that. Entire careers have been murked for those reasons. I'm happy to give credit. I like giving other people credit for stuff. What I'm doing is I'm spacing this out a little bit more so that the traces make more sense and I don't have these weird little ends sticking out of everything. Why is that moving in such a chaotic manner? Oh, because I'm hitting Windows instead of Alt. Apple did quite well. Apple's hardware design is pretty beastly. They're good at, like, if you take the time to look at one of those circuit boards, holy, they look good. They do. Their hardware design is on point. I don't know what kind of advanced programs they're using, because these software suites that design electronics have like AI and stuff. They're scary. They are scary pieces of software. What happened there? What has occurred? I'm dealing with a grid right now. When you design circuit boards, everything it resides on a grid. And the little end piece to connect with the grid is sort of the part where things get chaotic. Oh, all the Apple apps exposed to vulnerabilities. Oh boy, that's it's a thing. It's a thing. I hate that jump right there. I don't like that. That doesn't look right. It doesn't look right. Let's make it look right. That is completely cursed. Can I grab this and nope. I mean, my only other option would be to spread it out a little bit more. I don't want to do that though. And then there's a little end of the line in there that's keeping me from moving that. I'm sort of pseudo aligning them on a grid that I'm not really following all that close. That's just how things go with these sorts of things. That's kind of cursed. What if, even if I come up like this, it's still going to look terrible. I can squiggle it in. No, I can't. I've unsquiggled my squiggles. Yeah, one of them is just going to have to look dumb. That's a little less dumb. Wait, how the heck am I supposed to... Oh, that's on the top. That's not actually going to this pad. Okay. There's a capacitor on the other side of the board, and the air wire is still shown. And that's also coming from that. Those are decoupling. I guess I'll do the decoupling lines. I'm using 0.4 millimeter for power traces just to give it a little bit of extra copper. There really isn't any strong reason why I'm doing that. You know, sometimes you can fool yourself, but these are low current. I mean, they're designed to output audio signals. It's going to be very low current, lowish voltage stuff. All right, so that's good there. These need to be run. Oh, wonderful. You go like this, right in the middle. These are... My placement of these things is more decorative than anything else. This is going to go up this way a little bit. I'm going to bias this one so that this big trace is right in the center of the chip. Actually, wait, those are grounds. I don't care about grounds. Get out of here. Escape, escape. What's going on? I can't... bug in the program. I can't hit escape. There we go. It's because I hit something weird and it like focused on something else. So yeah, I'm not going to worry about grounds. So let's just take 3v3 and just put that directly to there. And I can keep that in the center. It'll look good. Cool. Okay, those are both grounds. And then we've got our unused circuit here needs to have a trace on it. And that's going to be a signal trace, so I'm going to take that down to 0.3. Part of the way that I'm doing this is also just that I know how Seed Studio likes their PCBs to look. I've done quite a few designs with them, so I sort of know what size traces I like to use, etc. There's just all kinds of little things. Well, that's going up to there. I can actually get that on this layer. We can just take that down like this. Well, well, I don't know. I don't know, partner. How are we going to get out of here? Certainly not that way. There's a big keep out area on that part. And if I do this, I mean, it's kind of close, but I guess that'll do. We made our first external connection to the outside world, and it is super roundabout, and I don't think I want to live with that. I don't want to live in a reality where that's okay. Nope, 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 nope. I don't think I want to scooch that any closer, because then I could make room for a second trace to go through here. But I think what I'm going to do is just take the resistor out of that side of the thing. I can just put that right here. And put it right here. That's fine. Although technically that C5 should be in the route of electricity from the pin, because C5, what it's doing is it's not just a capacitor. That's actually a electrostatic discharge preventing device. Log4j vulnerability. Oh yeah, I remember that. Some library somebody made for logging and it ended up being blocked in like 90% of Java apps. Man, I remember that. Yeah, I guess that's what happened with that. Should I put both parts? I don't want to put both parts on the outside of the board. I want to kind of keep it clean. This was I had no choice in this to put that there. There's no other place that'll fit. I mean, it would fit here, but then I wouldn't have room to put my circuit. I'd have to put my circuit around this stuff, and I don't want to do that. Let's see here. I mean, like, okay, so that, even though it doesn't look that close in CAD, that's too close. I really want to keep stuff away from blocking. Oh yeah, that's right. That's on the other side of the board. I keep looking at that and going, wait, something's wrong. Oh god, it blew up. It blew it all up. Everything exploded. This is kind of hair splitting is what's going on here. Why is it subtracting from one curve and adding to the other instead of just moving the this CAD program? All right, I'm bleeding this, and I'm sneaking that trace up above. I think I can get away with it too. Yeah, I'll move this in a little bit. Everything must be perfect. I feel like that's going to be too close to the IC, but maybe we can get away with it. There's the keep out box is actually really nice to have on these because it keeps it so that I can solder it skillfully, not mess up. Put it down there like that. And then this can go up like this. Actually, I need the bend here. So that's got to go. What are you guys working on over there with Last Miles? It's funny because I made a note that I put on my wall to be nice to Last Miles. He comes in here and I'm like, what the fuck you guys? Typical bother. Right, 0.3? Yeah, we're still 0.3. There we go. Okay, now I have room for these guys. So I can put this there and then this in the middle, decoratively. Oh yeah, that's some good decoration right there. Okay, coming up and around. Oops. Route that up and around. It's very cute how the CAD program kind of pushes the other traces out. It's like, no, you can't go there. What do you mean no? What? Huh? Huh? Oh, it's the other side of the resistor. Oh, wait a minute. Flip it, flip it, flip it, flip it over. It's done. Okay, now I can sneak you this way. Did I mess up that bend? Nope, still good. Okay, cool. Now we just do one of these. I keep hitting the wrong tool. I hit unroute. All right, there, and then this goes here. And then we do a squiggle here. Nice little squiggle. Look at that little squiggle right there. I can't believe Flatulent Gonad streamed for like 8 hours. Ridiculous. I tuned into his stream and he had been streaming for the entirety of my going to bed, waking up in the morning, getting my coffee, taking the dog for a walk, the shower, the shave. No, I didn't do that. But all of that was in the time that he was streaming. Craziness. So that one connects to -10. Yeah. All right. I'm not too mad at this layout. There's a couple things that still need to be kind of snuck in. One of them is this capacitor on the other side of the board. I'm going to try to keep the vias free. What happens is when you center click in the CAD program, it will insert a via, and there may not be much room for it. So I need to actually move all this stuff out. And I'll just redraw it. It's faster to redraw in order to make room for that via. Via is literally a rivet through the circuit board, and what it'll do is it'll take your electrical signal from one side of the board to the other. If you're doing like a 4-layer circuit board, you can have what are called blind vias, which are vias that you don't see on the top or the bottom of the circuit board because it's an inner layer via. Don't mess around with those. They're not worth it. But in this case, we just have literally a hole through the board and then a plated hole. So the edges of the hole are plated. And these are, the only purpose of this is to carry this signal to the other side of the board. So it's not a lot of current. But these can also strengthen your board in some instances, where you would have a via go through your board and a pin would solder to it. It acts like a rivet. Or if you have a ground plane that has a via in it, it will actually strengthen. Like for instance, if I put a pin that was in contact, like directly in contact with the lead of the what is this, resistor, then it will strengthen that pad and keep it from ripping up if you're rip-roaring your solder through the thing at way too high a temperature. We'll just go directly into it like that. I like the look of having the traces all come out of the chips just right, and that's not what's going on here. They're sort of going directly in. They're not sort of like pulling into the front of the chip as they should. Does this warn you about mutual capacitance inductance between traces? I think that would be more of a simulation thing for it to do, and I didn't do any of the simulation stuff. So if it is capable of operating on that level, I don't use it at that level. Holy heck, what the hell just happened? Control Z. Thank you, sir. Control S. My other best friend. Control S. So this stuff here needs to meet up with the top layer. So I think what I can do is instead of going around a bend, I'll just put a via there. Route this, and then go up to even with the chip, as even as I can get, like there. Center click, that, and then you're going to this, to this pin. I'm not really doing much with the other side of the circuit board right now. I'm trying to just get the air wires to be not in there, not in the way. And then later I can come back and take a look at the stuff on the top layer. This is technically, we're working on what I would consider the top layer, and all the components are on the bottom layer. The big components are. Okay. So it is a little bit of work to lay out your own circuit board like this. You can try using the auto router if you're brave. The auto router can introduce a lot of weirdness to your board, but it is a a viable way to put together the circuit board. I like working on this level, though. I like actually designing all of the elements that go on here and being in full control. Without having that op-amp circuit over here, we can use this area for the power, and that'll make things a little bit more symmetrical with how things are coming in to the board. I want to do it vertically, though, because that way I can fit this big heatsink. I don't know how much of a heatsink this thing really needs, but I'm going to give it that. Going like this, maybe? It does kind of load that side of the board a little bit. I guess I want it up just a bit. The RP2040 is going to be using the most of this anyway. C4 was just a power capacitor. D1 and 2 are protection diodes that are often not included on these synthesizers. And that is a point of contention for me. They don't put a proper, input helping thingy-majig. They don't protect their circuits a lot of the time. And without that protection, I have seen my fair share of blown up synthesizers. That looks terrible. What's going on there? Let's see. I can miter this. Miter this. I don't remember what the radius was. Was it 1? Yes. Maybe we need to tweak this a little bit. Spacing, width, isolate, rank. If we take the spacing to 2, will it be even? Nope. 1. What the heck? It's like it's drawing that one side very weirdly. Oops. It's a weird polypore. Let's see. It was at 1.27. Hatched. But when I do that, it doesn't quite get to the end, which is strange. Maybe it's just weirdly... No, give me... Ugh. Yeah, it doesn't like to preserve. Huh. Janky. It's janky is what it is. I want to move it in a little bit, but the mitered corners are giving me trouble. Dog's barking at anything and everything. We need to teach her when we want her to stop barking. Oh, what is this? Is this a joke? Hey. My grid spacing is fighting me. I'll just make it the width of the actual piece there. My only concern, though, is that I'm blocking an area that signal traces can go through, so we'll see how that works out. Oh, I gotta center this a little better. Looks so, why is this one extended and the other one isn't? What's going on? Wait. Why is that a different length? Hold on a second. Curve 0, width 0.4, spacing 1.27, isolate is 0, thermal, I don't have any other control over it. Look at that, that's longer than this. The one on the left and the one on the, any of the mid ones. Why is it doing that? Is it because, I don't know why it is actually. Why would it do that? Maybe the two ends are, but that is clearly, the one all the way on the left is clearly longer than the one all the way on the right. It's doing it as just a means by which to fill it properly. So if I select this whole side and drag it inwards just a little bit, yeah, now it's more even. Huh, that's annoying. Well, whatever. There's my heatsink patch. I gotta center the part on it, though. Actually, I want the part to stay on the grid. I need the actual heatsink to move. Let's grab all this. I could use numbers. Probably should use numbers. Oh, that's not helping at all. How can I do this? Because if I drag through here, it's going to select that. And then I guess I could just hit shift and unselect it. And unselect it. And then it unselects everything. It's stuck. Happy partner anniversary. Thank you. I had no means by which to turn that off. They forced it on me. Alt spacing. Move this. Move it a little bit more center. Oh, it's between one extreme and the other, huh? Well, maybe I can just do this. Oh yeah, it's going to be uneven no matter what. This is where asymmetry sets us free. There, just like that. I don't know if that's really going to be functioning very well as a heatsink pad. I could always put a I could always tell it to not put a solder mask on that, and then it would actually be more of a heatsink. I guess it would be better if this were just a big piece of copper that I put this into, but I don't really know how much heat sinking is really going to be necessary for the circuit either, so I'll just leave it as it is, and hopefully it'll be all right. Okay, so we're still going with this design. It's just piece by piece by piece. And then when you look down at the clock, you're like, holy crap, how much time has gone by? I would have very much enjoyed designing circuit boards professionally. I was trying to look at that as kind of a career, and then I talked to the guys who design circuit boards, and they said, don't do it. They're like, it's terrible here, don't do it. And I'm like, oh, okay. All right. So much for that ambition. Yeah, if I could come diagonally out of this. I don't like using diagonals, though. Do I do diagonal on this? I guess I don't have much of a choice. Although, yeah, I don't have much of a choice. Ooh, that's terrible. There, I'll just do that. That should be curved. Can we not do curved diagonals? I guess I can squiggle it. I can squiggle it in. That's going to block stuff, isn't it? Getting the signal traces out of here is a challenge. There's a lot of stuff. But I do need to do like power routing and stuff like that first. Yeah, we got a lot to go here. Which one? C4 is... I guess that's output of 3 volts, so this one should be somewhere around here. We'll do one like this, R10, and then we've got the capacitor on the other side of the board, and we've got our 10 volt creating circuit here too, which I guess we can just park that right there. That's right by power where it needs to be, and then the 10 volts. This is actually doable in, it's a very simple circuit. So power in and 10 volts out. Yeah, it's just a one line between all of these. What's going on? Do this, and this is just a reference voltage. This just allows the equipment to know what 10 volts is, and then, you know, utilize that in the math of the different components. Yeah, we're gonna have to jump layers in order to get in there. I don't like going through the middle of components for traces. I mean, I guess that's doable, but I don't like the prospect of that when we can just jump to the other side of the board. Where else needs -10? It's really only that spot, is it? There's 2 things that use -10 reference here, and it's both sides of the MCP 6004, the 3 volt op-amp circuit. Oh, my head! I've had a friend that does design, not so much the circuit itself, but arranging the components, vias, etc. He used to work for Amcor. There's a name I don't think I've heard. Yeah, the stream, the what is it, partner anniversary, that's fine. It's fine. It's just funny that it was a thing that I could not turn off. I was unable to turn it off. Where is our via going to be in this area? Oh my god. I can go all the way out to here without running into too much. That's a bit of an ask, though. Our via is going to be about the size of that one, so I guess I'll just put it right here. That's a nice spot for it. That's a nice via you got there. Would be a shame if somebody bumped into it. Bump, 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 bump. Okay, let's put that right here. Bonk. And on the top layer, we are endeavoring to get closer to here. So I'll go down here and then allow this to make its own bend. And then, actually, I'm going to come right up to this thing. Let's do that. Bada bing. Now that is obviously going to have to be moved 100,000 times because as I wire everything else up, traces are going to get in the way and stuff that I want to go directly. This does not have to go directly. It is a voltage reference. Although technically, if it's a voltage reference, it probably should get a pretty clear line on its way because you don't want other stuff to like interfere with it. I don't know how much that would actually happen, all things, you know, being considered. Running DC through a decoupling capacitor is fine. Yeah, why is it not? Are you looking at the old messages in YouTube? YouTube, we don't get a lot of chatters in YouTube. I strongly encourage YouTubers to pop on over to Twitch, but you guys can talk in YouTube as well if you feel like it. I just don't. I only see you guys on my the dual chat. You guys get the little red icon. That's why I miss all of these alerts, all these things, because I'm not looking at this window. I didn't know that Last Miles took like 1 billion people and shoved them up my patootie, up my streaming patootie. Last Miles is cool. It's a good stream. I peek over at the alerts every now and then. I need to get better about that. I'm on 3 monitors now. I had to get a 3rd monitor in order to stream to YouTube simultaneously. Also just because I wanted another monitor up here. And so I am sitting here with 3 enormous monitors just flanking me. One of them is almost all the way behind my head. I get the wondrous view of this here. I didn't do a proper like shop tour or anything. We're working purely on the computer today. But like, this is what I get to look at. A nice bright light and then one single CAD window that's being encroached upon by chat. And that's sort of what's fun is that the view of the 3 windows. For me, it's chat. For you guys, it's, you know, the desk cam and chat and the face cam. But yeah, it's that's how I organize things here. I don't do green screen bother in the corner because I've got all this stuff behind me and it's fun to have in the background. So you don't get green screen bother here. But yeah, I don't get a very glorious view, and all the way behind my head is the window with all the alerts and stuff in it. This is basically if I need to moderate anything, I'll go over to this screen. It's a whole thing. It's a whole setup. Yeah, Burn the Subs is still back there, neglected, unfortunately, and my new oscilloscope that's got all those cool features in it I'm not using. I haven't used that thing in like a month. It's annoying. When these things come in the mail, we'll use the oscilloscope again. My brain is turning gelatinous. I'm starting to lose my mind. Mind is a terrible thing to taste. R20, how are we getting over to you? Well, I guess we'll have to jump to the other side of the PCB for R20. And we'll put R20 like somewhere around here. These have got this one has to go to a pin up here. And we'll need our power layout to be in there. The one that goes to the pin will probably go to the very edge over here, which means that it's probably better to put, I don't know. Oh, you have to go all the way to the outside of the board. Wait a minute. Oh, I see. There we go. Yeah, any of those connections. And I don't want to run stuff through C15. I could move C15 over to the right, and then I would have access to that, but it would also make my layout a little weird. If I go from here, I built a tiny digital oscillator from a kit I bought on AliExpress. It was a blast to see it actually work. Yeah, that's cool. It's always great when you get your circuit to actually start frickin' functioning instead of just being a source of stress. Which is where I am with the VCOs that I have for the analog VCOs are just, I just start hearing white noise when I start working on them. They're so complicated and I just don't know what the hell is wrong with them. They're analog circuits. That's really the big thing. Analog circuits are such a pain in the butt. Am I okay with that? I guess I'm okay with that. And then this, I want to, well, what are we doing? Let's see. I can do down here. There we go. Yeah, the 0.3 millimeter traces can stack up pretty nicely when they need to. It was too soon. Which VCO did you build? So two of them, and one of them is a Bic and Tick filter, and the other one is an X4046 VCO. And the X4046 VCO uses this like matched pair transistor oscillator that I don't really know exactly how it works. It's just basically the transistors are so well matched that one I don't know, one moves the other in a symmetrical way and it makes a sine wave. And I put the whole thing together and all the parts should be right, but nothing works. Everything is weird. On the Bic and Tick, I get a clock signal, but I don't know what the hell else is wrong with that because the Bic and Tick filter was a fun one because it was built for a larger rack, and I just put it on the side of the rack case and snapped it. I snapped it in half, and then I soldered wires to all the different pieces of it in order to repair it. The only problem with that is that now I don't know what the problem is. Aside from my own shenanigans, I don't know what's wrong with the 4046. That's the one that's should work and does not. But they are complicated beasts. Complicated, strange beasts. I feel like I want this one to exit going south. I mean, if I move this over to this side, I could potentially get this part of the circuit to go up. Just the one trace going all the way up, and then this one goes out and around. I think I like that better. Nah. That's true. I can't really work in this area. Like if these were up here, and then this is a little convoluted in this area. Convoluted. But can I actually get, well, I need this trace to be here, so no, this is cramping everything else unless I bust it into the middle. Speaking of analog circuits, oh yeah, I have a CEM 3320 VCO as well. Or no, is it 3340? Hold on, let me find it. It's in the rack right now. That's the only one that I got working. Yeah, Bic and Tick X4046, and then over here I have a 3340 VCO. Yeah, same thing, and I got knobs on it now too. That's the one that actually worked because it's all in an ASIC, so I don't have to have weird external components that don't work. The hardest one to get working so far has been marbles. I bought a marbles PCB, I got an STM32 knockoff programmer, I got the whole thing built together, and 3340 is the VCO, 20 is the filter. I should get a 3320 thing because I'm lacking filters. I can now make all the tones. I can't do anything with them. They all sound like VCOs, so I'll probably have to pivot and get some filters or see if the RP2040 can do filtration. If it can do filters, that would be awesome, because then I have 10 circuit boards of each design that I can do filtering with. That would be pretty badass. Yeah, so the 3340 was amazingly simple because it's just an ASIC. The hard one was marbles because it's so small. the technology, when you get into smaller sizes than what I'm doing right now, which is SOIC and 60 something or other, 0603, that is the human minimal size of soldering, right? If you go smaller than that, the 40 whatever 0402 and other IC packages, you get into the machine solderable sizes, and everything on marbles was built with the machine soldering sizes because it's meant for production, not for some hobbyist like me to come in here and start bitching about how small the circuit is. So I was faced with quite a few traces and, well, quite a few soldering pads that were just impossible. With marbles, everything seemed to be broken, and since all the software is just like, here's my software, don't talk to me, don't bother me with this, there were pieces of production sort of stuck in the actual code that were not implemented. So there were things like, oh, this thing here actually has something I could test these pins on, but I'd need to implement it in the software, and I didn't know how to do that. I wasn't too familiar with the STM32 environment. So I ended up actually messaging a YouTuber, Toil, who does a lot of DIY mutables, instruments, module stuff. He's got a couple builds on there. And we were both just scratching our heads at what could possibly be the problem with these units. Well, it turns out it was me. I was the problem, and it was my soldering that was the problem. There were some things that I needed to go over again in order to make sure that they work. It was madness. It was just so frustrating, so frustrating. But yeah, it turns out that just literally going over, I was testing voltages on the board and testing out what the resting voltages were and stuff. And it turns out that my soldering was not up to snuff. It was my fault. All right, let's go to big traces here. 0.4. Let's do it directly to those. I want to keep these kind of clear and simple and keep them away from other stuff because these will explode. These diodes will be the thing that explodes when everything goes wrong. And I've seen it too many times before. Klein VCO 40106 plus 074 works great. 5 octaves for 5 octaves at 1 volt per octave. I'm sure the comment was much smoother in your head. It was not smooth in my head. My head did not like it. It jumbled it around. Do I want to flip this around or not? I want this actually to be a little closer in. I don't want it to be this close to the edge. I need it to be a little closer in, a little bit more centered on these, and then I think I'll have an easier time of it. But the negative voltage is there. So that calls into question whether or not I want my negative voltage to be generated here. This is the only good space for this. There's no other good space for that. So that's fine. U2 is okay in its location. But if I flip this over, then it'll be a logical progression over to the voltage sources. So that's flipped. And bring it in just a little bit. The only problem is these are 3-dimensional. These are going to be solder pads. So if this is colliding with that, it's bad. So I need to keep it outside of that footprint. So I guess I have no choice but to have this all the way up against the side here. That sucks. Yep, I got no choice. This is how it's got to be. So we'll work within the means in order to get this thing together. I could put D2 down here and then run that there. See, it's just much cleaner. Oh wait, no. We flipped it, so it should be. Yeah, I moved the diodes. I confused myself. That one there, this one up here. Of course, putting this like this means that we're blocking this entire area to traces. That's a tough one. Building modular synthesizer stuff has been very interesting. Yeah, the shroud is not on the same side as the pots, but the pots have big pads that will get soldered. And so I can't get, like, this whole pad is a no-no space for the shroud. This is not an exact replication of what this is going to look like, but this is close enough to the pin headers that I have. I probably should have gotten a different model. So there's some more detailed models that take into account like the filleting on the ends of these pins and stuff. You can even see like the Seed Studio one did. Sorry, I keep zooming in when I don't mean to. Yeah, this is kind of a simple model, but it'll do. I missed the text over there. I got to do all this little I got to do a detail pass on this one before I order it. Point 4 is going to be our power trace width. I'll just go like that with both of these. Let's move D2 to be symmetrical. We're just doing it to be fancy. I guess I could go directly. Yeah, I might as well do it directly. That's a little bit asymmetrical. Let's go over here. And then this is our negative voltage. Yuck, I don't like either of those options. I guess we'll go just pipe it right back in. Go there. And then our next stop is the opposite side of the IC, of course. Of course. And we've got a trace that's literally like right on top of this thing. So I guess I can take this just straight out. This is like Via Town over here. This is where all the Vias ended up being. So many Vias. All right, and then this can go... oh, what the... That was a little weird. Where are we going? Somewhere around here, and then we go up here. Carefully. And then pop back up. There's a negative trace. It's winding its way around quite a bit of stuff. That's everybody hooked up to negative voltage, huh? And then positive 12 is coming from all the way up here. So what can I do with that? Well, first of all, positive 12 needs to go into the voltage regulator so that we can get 3 volts out, blocking even more space. A bunch of 074s I brought from AE turned out to be fake. Oh my God. I don't want to think about that. I don't want to think about that. That would make me very sad because I bulked up on a lot of those components recently, and I haven't found any that are fake yet, luckily. I really don't like what that's doing. I guess I can put the cap over here for negative power and make that trace make a little bit more sense. Where's AE? What is that again? Is that English? Where's our other two? Here are our other 2 power. AliExpress. Okay, yes, thanks. Listen, my brain does not have a lot to work with right now. It's when I'm doing stuff like this and streaming at the same time. Be careful, don't tap on the glass. You'll scare the streamer. These caps are really going to be kind of in the way, aren't they? I don't know where else I can put them, though. This is where they want to be. See if I can line them up maybe over here. Their positioning will also be affected by the 3-dimensional model. Well, it's funny because you have different perspectives on these, on the circuits like this. You're like, your 3-dimensional impression of what should be where is much different from your 2-dimensional, and much different from like when you, well, view the schematic. But like, I'm avoiding certain things here that I don't need to avoid, like that heat pad. I don't need to avoid that because it's not on this layer. I shouldn't have to be cognizant of that position. This one is in the safest of all spaces, this one here, just because it's in a big empty area on the board. And what I can do actually right now is I can just jump into the 3D circuit board to take a look at where those caps are. So let's jump into the 3D circuit board, and that's going to have to generate. It'll take only a minute. It doesn't take very long. This level of rendering of a circuit board was like unthinkable 10 years ago. But it's so awesome to be able to just, oh, look, there's a 3D model of my circuit board, just ready to go. That's the old one. It's going to get replaced by the new one. I remember buying 50 of the iPhone 4 charging cables from AliExpress seller years ago, and half of them were dead right out of the package. My worst one was my 3D printer. And I don't know if it was AliExpress or eBay or whatever, but the 3D printer was powering on and off even though I'd turned off the power switch, and the power switch was only hooked up to the hotline, right? So it was cutting power completely from the board, from the board that was running the show. But yet it was still intermittently powering on. Why would it do something like that to me? Why? Oh, why? Well, it turns out the power cable, and we learned this from cutting the cable, the power cable flipped neutral and whatever the phase pin was right at the plug end. So I kept that for a while. I had the plug end sitting over there by the plugs because it was a lesson in checking your stuff. I didn't think it would be unthinkable for that to happen, for it to be reversed like that. But apparently it was, and it caused me problems. Yeah, I guess I can stow the big caps right over here. It's kind of lopsided, unfortunately. We're getting out of the part where I can design this to be cool looking and where we need functionality out of this stuff. So packing all of these caps over here, where previously I'd put the text. It'd be, you know, with these audio boards, it's fun to be sort of creative and design things to be in particular locations. And I could always flip the caps and put them on this layer, but I wanted this layer to be a bit immune to the, what do I call it, bullishness of musicians with this equipment. I recognize that damage is very easily done to these things. After Julian went on a tear of buying up broken modular synthesizer stuff, I realized that, you know, if it can be pried apart, it will be pried apart and forced and broken. So, all right, let's see here. Oh, that's the wrong one. I'm actually going to close this one. Yeah, the chord VCO is quote unquote done. It needs a detail pass, but that one is done-ish. It's the actual chord VCO because I named the files wrong. This one is the chord VCO. This one, I mean, it shouldn't even be called the chord VCO because this one is the feature that this one has is that it has an extra knob that allows you to influence what the micro's doing. What's going on here? Uh-oh. Why is this one? Oh, this one's an old part. Or is it? I think these might be old parts that need to be updated. Because those should be even. And this one's a new part because I put it in recently. These are the old parts that need to be updated. So I need to go, and here's the trick. If you're editing the 3D models, because you've got a 3D model that has the pads and everything on it, right? And if you want to mess around with that, you need to update it in a particular way. This is the one that's off. I see. So I need these all to update to the modern version of the part. Actually, I think this one might be a different part, maybe? Okay. Yeah, I think the package is wrong. So I need to go all the way back to the schematic for this. That's not the schematic. Where's the schematic? Evidently, I don't have it open. Oh, yeah, that's right. It's in the other window. Hey, what you doing over there, bud? Come on back in. Okay, so the one that I added is here. Properties. Vertical pot, PS4 version 3, whereas the ones that the good ones are vertical pot, PS4 version 3. Okay. Mechanical managed. So what I was able to do, and I forget how to do it now, is you can update the parts to their latest version, and I forget how to do that. I don't want to remove, like, I don't want to move these. These are part of the specifically positioned components in this design. So there was a way to do this, and I forget what I did. Library. Oh yeah, that's right. It was on the library page. Super intuitive. Go all the way to the library page, and under the libraries tab, update design from all libraries used in this design. And that's going to update those parts, and hopefully they'll permeate through the chain here. I don't think those positions are going to change at all. Are they an even distance? I'm going to have to check on that. Let's go to here, and we'll push this design out, and that will fix the location of the three control knobs in here. I had to learn this the other day because I was updating the 3D models, and nothing looked right, and nothing was updating. Then it turns out, when you put the part in, it kind of locks in that part, the version of the part that you used. So go here. Those don't look like they're evenly spaced. I think R2 is out of order. Let's double check on this. I can use the inspection tool and go from circle to circle and get 18 millimeter. Oh, God. Yeah, they're not. 15.607. Let's check what this is. So I think both of them are off by a little bit. I need to correct this. All right, let's look at the front panel and see how that's set up. The front panel is a separate file. Oh, we're in marbles. Let's get out of here. So front panel is RP2040 VCO, and then 6U VCO cords. I should have probably come up with a naming convention early, and I didn't. So everything is just random, horrible. Are you evenly spaced? Or are you an example of here to here, 16 from center to center? We got 18. I guess 18 max? That's a different result. That's a third result that I did not expect. 32. So 16, 16, 32. I'm going to have to figure this out. Well, everything is measured from this bottom corner of the circuit board. So I'm going to do a square, and I'll grab this, and then we'll go up and to the right, and then we'll add 16 to that twice. And so my coordinates are 15 is in the middle, of course, because it's 30 wide. So 1563. That's not going to affect us here. It's going to affect us here. So the first one is 1563. It is. Okay, so 1563, so it's 63 plus 16. Calculator. I'm going to get the calculator out. I don't... Oh, man. If you ever want to, like, experiment on the brain, try to figure out what's going on in people's brains when they're giving a presentation and they try to do math. Because there's, like, a strong disconnect between one's ability to actually do math and their ability to do it while on a stage. 1563, 63 plus 16, 79. 79. I have a feeling this one was bumped by the RP2040 when I was moving around. 95. 97. There we go. I corrected it, and I just need to kind of move this resistor down just a little bit. Nope. Selecting this is going to be challenging. Nope, I'm gonna have to redo it. It's not gonna go quietly. Oh my god, my dog is just barking at everything. She angry about something. Okay, nice spot right there. This needs to be a little bit, we need to handle this one a little bit more gracefully, because it, that pin is right there, it's right in the way. I'll figure that out later. Now I'm just gonna push this to the 3D model, and that'll hopefully make a little bit more sense. The grip point of this thing is off to one side, and I don't know how thick it is, so I don't know where that center position is. It's right now it's at 23, and I don't know what the length of this line down here is. Can I measure stuff in the 3D model like that? Let's see. I can definitely measure the width of the board itself, but I don't know if that's going to be reflected in the size of this line down here. No, it's just that it's no, like, there's no thickness to it. All right, I guess I can go by the board and see if that's the center position. They put the grab point off to the lower left, which is not useful. So if it's 17 and a half and it's at 29, well, 17 and a half, and I need to get, so 17, wait, was that really 17? Was that the right number? I forget. I already forget. This is, again, getting into math and positioning these things. Oh, it's in an isometric view. Ugh. Let's see, 17.5, that's going to be a cursed number. 17.5. Oops. 17.5 over 2. So 8.75 added to get to the center. So it's 15 minus 8.75. 6 1/4. That doesn't make any sense. It said its position was like 29. .8 by 85.3. If I make this, no, if I make it 30, that's not going to work. 80 is the height, 23 is from the edge of the board. 15 from the edge of the board is there. And it would be 15 minus, unless it's actually represented on the other side because we flipped the board. Ah, okay, so I need 15 plus. What was it, 8.75? There, 23.75. That's more like the number we got. 0.75. Bonk. Now it's centered. That didn't really do much for us, but at least we know it's centered now. This is cursed, though. The one pin that I need to get to is the one that's almost only exclusively blocked by this part right here. And there's like barely enough room. P6 is not going to be able to exit in this area. We're 0.3 because we're a signal trace. 0.3. Oops. And then I exit the tool. Not on route. We want route. There we go. Boop. All right, there. That gives it a little bit of space to function. Rip up this trace. Boop, boop. Yeah, so I kind of jump around. I'm kind of jumping around as I do these from thing to thing, trying to make sure that everything can exist on the bottom layer of the board. So I was going to do V negative goes over to its thing over here. I guess I can pull that on the top layer and go around like this, and then just drop that down there and go there. And I actually have to make that a bigger trace. I mean, technically it should be hitting the capacitor first, but can't win them all. And actually, before I even do that, I need to make sure that the caps are all lined up with each other. So let's take a look at the top of the circuit board and let me line up these components so that they're in a good position. So I want to change my view to preset top. Bonk. That shows all the relevant top stuff. I can get rid of that window, and I can then flip the board so that it's all the text is correct. Oh my god. Oh yeah, no, it's fine, it's fine, it's fine. It's all good, it's all good. Just move the stuff that I don't need to see off, and then I can get the other stuff correct. Now this isn't when I'm done the design. What's the date now? Well, I'll keep that date on there, it's okay. It's not vital that the date be perfect. These components are all kinds of cursed. They've got all these like misalignments and stuff. I don't know why they're like this, and I would like to fix them one day, because it really does affect the whole rest of your design when you've got these completely cursed components. Who made that? Ridiculous. Of course, the level of precision that we're talking about here with circuit boards is like we've got fractions of fractions of fractions of component values. This one should not be upside down. I do not want to allow that on this board. There we go. Kind of want everything to face the same directions so that you don't get confused when you go to build the board. Yeah, we got some signals to run here. So I'm now going to go to the preset bottom. Preset to bottom. And now we've got all these symbols here, signal stuff. Get in here. Zoom all the way in. And we need 0.3 millimeter traces. And it's just basically kill the routing wire is the goal. Do I want to do a power that's direct? It doesn't need to be totally direct. It can jump around a little bit if it needs to. And actually I can do top layer for power here. And we'll make that a larger trace. Of course the tool goes, I hit escape. I keep hitting escape. 0.4 goes directly out, but then I need to do just a little bit of, actually no, I could just do it like that, perfect. Except in the case that I need something coming out of here, but we've already routed that one, so we've got 2 layers to deal with anyway. So D1 going over to this capacitor. Can you use net classes to set larger trace with power nets? Probably. It's not something that I know how to do or do. It's not something that I know how to do or do myself. I can probably set that up in the schematic. Let's go over here and do like, yeah, I guess I could do net classes and stuff. I just don't know how to do it. And I could call them power nets. That way you can change their widths and stuff like that very easily. I just have never done that. I come from a time when the schematic layout was only a little bit more functional than MS Paint. And so I have not learned how to use these tools in a more complicated fashion. Try to kind of center those. These are probably on bad grid spaces now, so they're not really going to be that even. Oh well, they don't need to be super even. Preset bottom. I could probably also set up a shortcut for flipping the board and stuff, where it would flip what's visible. I just haven't learned any of it. And if I go to route a trace on the top layer, it'll pop the top into view, so I can use that. Where do I want this to go? I mean, I don't really want to move D1 to a bad place. Moving that like that, and then using the via as the corner is another option. Do that. I think I'll run them alongside each other a little bit. I wanted these to exit this way, though, because they're more visible like that, but I don't think I can swing it. What's this one? That's negative voltage. That's in a bad spot. I may swap the 2, but then I can't get to the top there. Oh, this will be, yeah, this is easy. Okay, hold on. You come with me. You go here. Give me this. Thanks, Jalopy. My partner-versary. Oh boy. Oh yeah, V negative comes from the other side, doesn't it? Okay, okay. I'm trying to free this area so that I can exit this properly, but it's looking a little bit more complicated than I thought. You sure don't want these things to be in the same spot. I thought I could grab the other side, but I got to get it down here. So excited for your accomplishments. Listen up. I get a rap for not finishing projects, and it's been what I've been concentrating on for quite some time. It's actually finishing stuff, but it takes a lot. It's difficult out here, and I have to survive somehow. I don't like any of this. I don't like how any of this is going together in this area. This power section is bad. What if I flip them? What do they look like? Yes, I know this is out of date, but it's good enough. Good enough. I have them all point upwards or downwards. Yeah, the easiest part is coming up with a project that you want to do. Then you solve a couple problems along the way, and then it becomes time to really refine what you're doing with a project and get it to a point where you can call it finished. That's the tough part. Keeping task-oriented and motivated. But I mean, it's what I do. It's what I do. I've got to be good at it. If I put 3 volts over here and 12 volts over here, and I flip them both, all 3 of them, in fact, flip them, and put them like this, then I can get 3 volts from out here as I send it away as well. Call them whips. Let's see. 1, 2, 3 in a row. Moderately, somewhat spaced evenly, not really. Let's start on the top of the board. Come over here. Pop up, go straight in. And then 12 volts. Where is 12 volts going anywhere else? No, it's not. No, of course not. Why would it? That would be preposterous. 12 volts I can get from down here, so I can actually swap these two, and then I've got a nice little tidy area where things are coming in. Where's the even spaced area? Why do they all seem off? They all just seem off all the time. It's these freaking SparkFun parts that are all bad. They've got like weird centers. I don't know what it is about SparkFun, but they decided that they wouldn't bother to make these components like on any kind of a sensible grid. Or maybe they use their own special grid, but it just does not work for me. I mean, technically I could come in from over here, bring that over there, and then 3 volts here. Maybe. A I don't know how to say that. Vocoder in the late 70s and still haven't gotten it working. It sounds cool. It sounds unique. Remind me what a vocoder is precisely. I'm inundated with decisions here that I've got to make. If I want to bump V negative down a little bit, then I can get 3 volts out of here and take it over to here. But I probably should put a via somewhere on this, which means that I probably should move the capacitor away from where we are right now. V negative can move down quite a bit, although it's making this look normal. Even though this is anything but normal, this is not great. That'll free up some room for traces to fly by if I'm going to be blocking this area. Might as well lean into it. And then this is too close, but I can't really move it anywhere unless I move this down. So this can move down. And then, but it doesn't, So it makes a robot voice. Robot voices is cool. My new mixer can do that. Newish, new to me. Mixer can do that. It does all the ha-ha funny filters that ha-ha funny streamers use to make their voices sound ha-ha funny. I forget, is there a change layer button? Like, can I flip from top to bottom with a button? I think I probably can. Usually is. Yeah, it's like intergalactic type. That's cool. I guess I could put the via just right here, but I don't like that. I don't like it. I don't like it at all. I'll just do that then. That's it's a little weird. It's just I'm more comfortable with the traces being like that. This is 3 volts out, and I don't know if I want to cross over to here with it. The more I do these vertical and horizontal crosses, the more I'm blocking off areas of the circuit board that I won't be able to access. So V negative. 12 volts is an easy one. I can just take that on the top layer and just go boip. Like that, which once again closes stuff off where I can run traces. But power's important. I gotta get power to everything, so. Oh, wrong layer. How do I want to run C4? I could take it from the other side too, but the other side, that's gonna access the rest of the circuit. I guess I'll just straight over. Just go straight over. You start to get decision fatigue from this stuff. Now, as much as I want to run this like that and like loop it around and get over there, I don't know what I'm going to be blocking when I do that. Oh yeah, and then the grounds I need to do this with. Bonk. No. Why does it? Cursed. I hit escape and it did cursed things. This connector is going to be in serious danger of connecting to the edge. Oh, that's right. No, those are going to be done by the ground plane. I don't need to... I need to run those. Okay. What next? I think we're getting to the point where I'm going to have to run the long lines up and down the circuit board and finally settle those questions of how I'm going to run the traces up and down the entire circuit board. -10, V negative, and then 12 volts. What else is using 12 volts in this area? Nothing. Nothing else is using that 12 volts, is it? And I got to get that from all the way up here, all the way down to here. So that looks like one of the first things. These are also, this one, V negative is connected. And 3 volts has to go to the MCP. Pants. I can kind of, I don't like that. Well, I guess the P's are the next thing. So let's get our long traces in, and those are going to connect the larger component pieces of this design. So the first one, you get the switch. Well, the lowest one is all the way down here, and that would be, is it P28 or is it R20? Which one are you? Okay, so it's from P28. So I'm going to run P28. I can run it in 2 different places, but I guess what I'll do is I'll just punch it out to a via. Oh, that's terrible. Actually, that'll organize the rest of it. That'll make it look better. Hold on. We can rip up this side of the trace. And then I actually don't know if I have room for that. Yeah, it does a cursed thing every single way I do it. Every single way it's cursed. Look at that. Disgusting. Disgusting. I guess doing it like that is the better way. Or I could actually take it and leave it the way it was and just come out at a right angle from this. I don't like doing that, but that's sort of bad. If I do that, but no, that's still going to be cursed as hell. Because look, if I come over here with this one, yeah, it doesn't, like, kill me. Why have I been allowed to exist? Okay, so what are my other options? I could put it in here and give it a three-way junction, but that seems a little sloppy. Seems sloppy to me. I could just give up and go home and never build the circuit. That's the way to go. Do it my way, chat. Give up. Let the cursed design flow through you. Ugh. That's, I don't know. I guess I'll leave it. It'll be fine. We'll make it. Don't worry. Okay, to the top layer. And we're just going all the way out to the edge of the board. I don't want to totally go to the edge of the board though. I want to keep these traces a little bit separated, but we have got a lot of these that need to be run. So that's unfortunately, that's as close as it'll let me get to the edge. So I'll go right up against it. There's one. Because, yeah, that's going to block ground from getting to this side of the connector. Which is an unfortunate thing. Those need to be connected, and then this one can go up like this. Or I could drop that whole trace down to the bottom, and then those will be the only ones that come from that side of the board. Because we've got two over here, and then we've got our three that go to the audio. So we'll only do two of these that go down, that go all the way to the edge. And I have one power that needs to come in too. So let's go to the bottom layer of the board. Put it on the board. Okay, bottom layer of the board. And then 0.3 still, and we're coming out, and we're going all the way up. All the way up. Up we go. There we go. So those two stacked right on top of one another. One's a switch and the other one is like an audio I/O, so they'll be okay. All right, we got power that needs to get into there, and I need to get that from here. And I think I can do that. Well, if I do that on the bottom layer, then it's going to get in the way of my little 3-volt heatsink, and it'll block anything else from coming up and down. Starting to deal with the consequences of my actions. all these little decisions that I've made have had consequences. That capacitor's going up, way up to there. That's going to be a tough one to route. C6, R6 is going where? To a different one? So capacitor and resistor both get different... No, connected to the same thing? They both say P26. Why does this one want to go all the way over here? P26. Oh, P27. It's just, it's lines on top of themselves. That's what's going on. I'm getting confused. This one's going to P1. Is that from somewhere else? P26. Oh, P2, there we go. That's where it's coming from. Okay, so let's get some vias on these. I guess I'll start with the one that's furthest away. Oops. I went into the Analyze tab. Scary. Simulation tab. 0.3, that guy right there. We're on the bottom layer. Start here. There's no way that I'm getting that out of here, so I'm just going to put that right there. Pop on over. And then we're going up to P2. It's not a lot of room for... Oh, God, what just happened? Get out of there, you stupid trace. What? Why did you decide? It just decided to, like, flip the way it was routing. All right, well, apparently that's where P2 is. Okay. That really limits us, actually. That's not very good. We'll have to get creative because it's going to get more and more challenging to get these traces out of here. Because, like, P3 would be best if it came out this way, but it's being blocked. Oh boy, this is going to get complicated quick. Now, P3 and P4 can be swapped based on how I want to route the traces. That's a fun one. But P26 is going to the other side of the board. And then, what's next on our little hell ride? P1, where are you going? 10, 3 volts, ground. Well, if I just do the next one up, that's P26. It's going to get kind of crazy. I have room for a couple more traces to bring us up there. So P26 is right here on the edge. Do I want to jump to the top layer of the board? I probably do, because I want to avoid my little heat sink. So I'm going to start on the bottom layer, and we'll just come straight out. There's plenty of room in this area, so I might as well just plop it down wherever until threatened. Look at that. See, it just switched. It just switched where the edge was being placed. All the way up. And it might... What do I want to do with this? If I jump over here, I'm going to be blocking a bunch of stuff. I guess I need to cross over. Just making a big wall of red that I can't get through. Don't like it. This is one of those pins that has specific functions. It's like an analog, so I need to go to the right pin. Although a little bit of swapping can be done. I don't know quite what the level of that is yet. And then the classic move of jumping around a pin here. P27 is just going to the pot. That's nice and easy. Although keeping it on this layer of the circuit board is not, because D1 is right there. Jerk. What a jerk. And then this one also, Okay, that'll work. Okay, this works out. So I can go just to here. Jump layers. So this, I mean, this is like every factory game ever made, building a circuit board. I'll clean this turn up in a minute. Oh, look at that. I've blocked myself already. Damn it. Why are these all in the wrong order? That's the other part of this. They're like the exact opposite order that I need them to be in. Ridiculous. A little bit of pin swapping could also help here, but I don't know what the specific functions of the pins, like which ones are the analogs and which ones are not. And I could make that decision and flip them. I could also... Well, then where would I get 3 volts from? I was saying I could come in from the other side of the PCB, or the other side of the pin header, to get to them in order. That would automatically flip them. I like how they added the name of the trace that's on there, so you can see that there's 2, and they kind of separated them out. It's a nice little feature. If you've got 2 traces that are the same size running on top of each other, it'll list them both, and the listings don't collide with one another. It also makes it a different color, but it's kind of very close to red. So if I took... Like that one didn't have to change layers, but now it is in the way of both of these signals. And I can't really get it out of the way. And they come in the opposite order, so it would be nice, and I can't do it because this stuff here blocks it. If I could get under this and come in from the other direction, that would solve my problem immediately. But I can't do that. So if I jump to the other layer, then I have to do like a stack up. So if I stack it up and I move this down here, what the hell just happened? Oh, I'm still in the layout tool, still in the trace laying tool. So what I need to do is just do the opposite stack with these. So that'll go there, and then this one will come up here, and then change places. That's a little hideous, but maybe I can clean it up later. All right, P1 and P3 are going to the speech, and the speech is over here, and then we just need to do power. And then it's positive 12 and positive 3. Those are the few traces that I still have left to do. Oh my god, my dog is freaked out. Brr! What could possibly be so important, dog? I guess we're going to have to jump up layers here. So I'm going to need 2 traces to make their way up to here and then bump down to the bottom where they'll be able to make a connection. That kind of sucks. I don't like that at all. Yeah, and 3 and 4 are best gotten from over here. And 3 and 4 can't... Well, they can... I mean, they can enter in either layer, but if I could move those... I'm thinking about whether or not I want... Like, can I move these in and then still get to that location? But I would need to get to the other side of these, which is doable. I mean, I guess I can route them in through here. Easier to make the traces a little bit more uniform, though. Let's see here. Top layer. Come out here. To the novice, there are many solutions. To the master, there are few. Oh, there's a trace right there. I didn't see that. Well, we would be turning at that point. So it'd be there, and they would have to like go out, down, and around in order to get to the right location. Because as much as I can meander it through here, I can't get past this. And that changes layers. If I change layers over here, well, there's still a lot of like wiggling and waggling to get around this stuff. So I'm trying to keep it kind of simple. Which never works. Never works. Oh my goodness. My dog is barking at everything. I don't know what her problem is. She's getting yelled at right now for making a ruckus. Quit instigating, doggy. It's funny how clustered the traces on this side are. And I think that's mainly just because, you know, that's just where all the stuff needs to be routed to and from, but I didn't decide to use the end of this wire that I have right here. Gotta get rid of it. Goodbye, goodbye. Recommend putting all your SMT components on the same side if possible. Yes, I know. And then you can use this. I have a hot pad in order to solder with, but this is a design that has a lot of different components on it. And putting the capacitors on this side subjects them to the musicians. This, having the caps over here, protects them. And seeing as the types of damage that I've had to deal with on these boards, I would like to keep those capacitors on the protected side of the board, because these guys really kind of put these things through the paces. I'm even reluctant to have headers on the micro, but that's just it just has to be like that. yeah, the things that I've seen, the types of breaking that occurs in these designs is insane. Can I? Well, this one I can't get out of here. I don't have a place where I can get that out. This one I can, and I could run that for a little bit. I could run that above P4, and that would get it to the right side of the thing. But, or I could do the classic going down and around, and then everybody's on the appropriate side to travel up to the top of the board. Do I have any other avenue here? Not really. Not really, unless I really wanted to get super close to the side of the board. I can, but that's not really going to help me. I don't know. Having the SMD caps on the other side, those are hand solderable anyway, so it's fine. I mean, it's all hand solderable. This isn't super high technology, you know? So P3 and P4, I need to go up here to where I can actually get to them. So let's take P3 is going to the bottom one. Yeah, that's correct. So we're going to do that, and then we're going to deal with the consequences of doing that. There you go. Yeah, it is something that I try to do. It's just not 100% viable in this design. It is something that could be done, but I don't want to. Whoa, that was weird. I don't know how, if these should be using the DRC, the design rules from Seed Fusion. Oh, I'm not going to be manufacturing these like that. No, no, no. That's out of scope. This is a personal build. Funny, I could do 26 and 27 up over the top, but that would still put them in the wrong place. Actually, it wouldn't put them in the wrong place. But I feel like up and over is a little bit like going over this right here and then down. Because then they're out on the outside there. Maybe that is the best thing to do. Sort of pull these in a little bit and then have, I guess it makes it, well, I don't like it. I don't like it, but then again, I don't have to like it as long as the traces get to where they need to go. Makes my front section look less technological. My cool designs. Oh wait, that one's fine. Oh, but that one needs to go to there. Wait a second. Oh yeah, P27's already run. Okay, never mind. Control Z. Back it up. Back it up. Yeah, okay, that's fine. So this is the one that needs to come out, and it's there. So I could get, yeah, I can actually get that one just fine. So let's take this and let's route that up and above and over. Up and above and over. So this goes around on the top layer, and then we need to make room. So I need to actually get rid of these two. Oops. Man, so many weird decisions, huh? I mean, I know I can use whatever system they have for creating the circuit board with, you know, auto routing or whatever, but I don't know, this is kind of fun. So this is going, which one is this? P26. Yeah, so that one's going to cut stuff off when it gets over there. But it is all the way at the bottom, though. So P20, that's P2. P2 is like way down here, right? Yeah, P2, 3, and 4. That's funny. That's the same area that P2 was from in the first place. So I can come from here and go up and around. This can go a little closer to the edge. Like that. Because it's 2, 3, 4 need to be in the opposite of where they are. P2, is that a special pin? Or can I swap that one? RP. Oh, Jesus, come on. RP2040 Zhao pinout. Very helpful. Lots of pixels. What do we got? So A0 through 4 are on that side, and then 670, P1, P2, P3, P4 are all digital inputs. All digital inputs. So I can swap them. Look, man, it's a $4 Raspberry Pi 2040. It's pretty awesome. Let's see, and we're basically our designs are based off of Hajiwo, and Hajiwo is using the RP2040, so I'm copying that basically. Where'd that window go? I have a window up somewhere. There you go, Hajiwo. Makes cheap modular synthesizer stuff. Pretty cool. All the designs are in Japanese. Well, they're schematics, so they're universal, but yeah, it's pretty awesome. I mean, $9 DIY cord VCO. Eurorack does not equal ITAR? What are you restricting? What are you talking about? Yeah, they can do quite a lot in these RP2040 circuits. I mean, there's also the what is it? The actual RP2040, whatever these were called. Where'd that thing go? It's like right in here, in this bin right in front of me. Here it is. The ones from Raspberry Pi that were harder to find, but the Pico Pi, there we go. But they don't have USB-C, and they're much larger. So these are nice for like little cheap Eurorack. Yeah, Pico. All right, let's see. I was routing traces, and my brain was starting to deteriorate as I was doing it. And so we're trying to get 4 lines down here. This one is going to P2. Why is that going into a digital line? Oh, that's the wrong view. We wanted to be on the same view. I need my schematic. Figure out what the heck was going on here. And I probably need to pull up the original schematic from Hajiwo as well, because we're going into P28 over here. That's our new input, which is just scaled with the fader thing. P26 over there. Oh, we're coming from P2. P2 is the output. So that output is going into our filters and stuff, but I guess it's not the analog input and the digital output. Let's just double check that we're doing the right thing here. That would be the cord VCO. Cord VCO V2. Pause the video because we don't need the video. I don't need to get like struck because of stuff. Look at more. This is a year ago. Oh my God. Working documents, schematics, etc. $9 RP2040. See, I was going to build this. I was just going to build this straight up, but I figured that making a PCB would make it a little bit more organized and clean. Nice and clean. Where is my schematic? See, Haji was doing it with the perforated prototyping board. Dang, he fit the whole thing in that, man. Well, we're taking principles from Mutable Instruments designs as well. Invert goes to P28. Audio output is coming from P2. All right. P2 is audio output. Now, can I swap that with P3 and 4? Because if I can, that'll make my design just that little bit easier. Two, three, 4. PA7, PA5, and PA6. It doesn't look like there's anything differentiating these pins from one another. So technically these could be swapped. And then I can get them into an order that I can actually utilize. So, I mean, part of this is that I can do pin swaps. I don't quite know how to use the pin swap tool. Oh, I think pin swap would be, I don't know if that'll work. Because then it'll call the net trace P2, P1, and P3. Yeah, $2 is a nice price. So if I swap all of these, that would mean P3 is now our output. No, P4. And then P3. And then P2. And then we can just go back to the board and they'll all be connected to one another. So now this one is P4. And that one has the biggest distance to go, but it will also enclose the other two, which works. All the way up here at our very limit. P4. Wait. Oh no, I messed up. I messed it up. I want P3 to be the okay, so undo that, and then we'll make P3. Well, let me run these lines in just where they need to go, and then we'll do the pin swapping. This one needs to somehow go to P26 though. Hold on a second. Plot thickens. All right, I'm gonna run them all the way up to the micro. And we'll see where we are with that. Because these caps might need to push in just a tiny bit, but the switch is like right there, so that's getting in the way. If you have two unused GPIO, hook it up to make a ring loop mod synth or whatever. Maybe instrument and modulate with your bandwidth drift. There are two. I mean, P0 and I don't know what pin 6 there is. That's ground. Pin 14. Oh no, but that's actually a voltage output. The voltage outputs are up in the corner. So 6 and 7 could possibly be connected together. That's a cool idea. Because yeah, I want this to be a little bit more universal. Because all this is two CVs in and then one audio output. Let me see here. TPL 7407. My goal is not to cost. That's why I'm taking the mutable instrument design and putting it in here. But our power is an LM117, and then I've got on my own modular synth rack, I've got an insane amount of power to draw from. I'm an EE, not a musician, so I built an actual good power supply into the thing. I got plenty of power. P26 is unique in that it needs to actually get all the way around things. So I'm going to have to put this all the way out here. Let's get the text out of the way. Yeah, but that's not my goal. My goal is to not... Hajiwo's goal is to save money. Hajiwo would benefit from that advice. I do not, because my goal is not to save money. I want to build a functional RP2040 cool circuit. This top layer, and then I gotta snake around this thing. I can just do it like this. I have no sense of honor here. I'm just doing it as best I can, as bestos I can. Wait, this isn't the one. Damn it, son of a bitch. Oh yeah, I've got to route this one now. I'll come back to the other one. So let's actually put this. Oh my God, decisions are haunting me. Haunting. My hubris. Okay, so right there. Yeah, my the power supply is way too powerful for the synthesizer. It's actually kind of amazing. I used components from. Why are you doing this? Oh, because we're on the wrong layer. from, what is it? Pololu.com. They make like robotics stuff, and so they've got some really genuinely powerful power conversion module type stuff. It's kind of amazing. I don't like this corner because I rounded the edges to make them nice. I guess that'll do. So I'll just do that. That's the ground plane is not going to enjoy this. But I mean, I guess I can alter this a little bit. I can do that. There we go. That feels better in my mind. So we are limited to inside of this trace here. Let's go like this. That doesn't seem like I got that all the way over. If it's willing to bump it over that far, I guess I messed it up. Okay, let's try again. Try again. I forgot to hit Alt. No. That's weird. It's willing to bump it further away than it's willing to lay it out. What the? Oh my God. The tool switching where the corner is automatically is really getting on my nerves. There it is. What's $1.79? All right, and I gotta live with this, but it won't let me get the maximum closeness to the trace. It just tries to blow it up. There we go. Right there, and then we go all the way up. B4. Yeah, we need to swap those. Undo this. Go back here. That's the wrong. When you pop out a tab and pop it back in, it puts it in a different order, and it really messes up my workflow when I'm working on this stuff. You have to buy $10 total. Choice items. Huh. I'm gonna have to buy a bunch of RP2040s in the near future. So we use name, P3, and this one, P2. I'll swap them and make my layout that much easier. Oops. Middle of my window. I'm starting to lose my voice a little bit. Last week I didn't stream because I was trying to preserve my voice. Why did that not? Speak to your manager. Where are we going here? Wait, P4. Oh yeah, you're supposed to be P4. Yeah, and P4's right there. Oh, it should be P3. I need to swap P4 and P3. I see now. I see now the error of my ways. Yeah, it's a bit much. I mean, if I really wanted to boil it down to being like my own design, then I would put the chip directly down on this thing, and I can do that soldering. I can you know, use an oven and reflow it. That's not P28 I don't want. I want. Thank you, Kung Pao Jeff. Appreciate you sticking around. This I want to be P3. And then we want P. What is the order of these pins? I last forever. That's not going to happen. Oh man, I am overtime a little bit here though. 3, 4, 2, 1. Is that really the order of these pins? I mean, this came directly from Seed Studios files. That's what's throwing me off. 3, 4, 2, 1. So let's get this. I'm so close to just finishing all the traces here. So P3, I want to be audio out, and then 4 and 2 are next to each other. Okay, so one of these I want to be P4. Oh wait, I was going 3, 2, 1. So the one that I want, I probably had it in the right order and I switched it by just not thinking, right? 4, 2, 1. No, 3, 4, 2. Okay, yeah, 3, 4, 2. Keep going into the wrong files. 3, 4, 2. There's probably a tool I can use to do this, but so this one will be P4. Okay, so that probably solved it forever. It did. Okay, cool. Cool. Keep moving. Can I help you? She's, I was like, you can't do that. I'm like, what? Excuse me? I'm the human. I can do whatever I want. You're my computer program. And then hopefully we've got room for it, because that's pretty stinking close to the capacitor. We can do one more from P2. Sneak it in. Without altering the position of the other. Man, need to like lock those down or something. Bada bing. Much cleaner. Not ideal, but much cleaner. Okay, so apart from a couple power traces that need to be run, should mostly be done laying this thing out. So let's just get 3 volts. Oh, okay, all right. 3 volts to where it needs to go. At a point, you want to just go completely to alternate spacing. And then, let's see, I guess we're going to take this from down here. It'd be a lot cleaner if I could run that. If I just drop here and then do this via, I can just go over to either of these locations. I feel like I should just connect those two, but I'm not going to do that right now. Let's see, 12 volts I've got to get all the way down to here. I think the best way is going to be jumping. Actually, no, there's not really any good way to do that. I can get over to here and then jump down. Okay, so first things first, there's nowhere to go here. So this definitely needs a via. So I'm going to drop to the top layer. I say drop because the top layer is technically the bottom layer, the top, the bottom. I don't know, man. I don't know nothing. See, that's, oh, Jesus. Help! Help! Why did it change so the way that I'm moving the mouse, I guess it changes the layer that the signal trace is on. So we'll just change layers here. This signal can jump all over the place because it's 12 volts. I guess I'll do one of these, to one of these, to one of these. This is going to be the most roundabout path. Oh, I hate it, but I'll live with it. I'll live with it. I can learn over time to live with that. My horrible crimes against trace layout. Problem is I need 2 traces to go through here. I ran into this problem with the previous version of this as well. I can either go above or below the switch, but it is a power trace, and I'd like to give it a little bit of breathing room. Yeah, it doesn't like that, that's for sure. So if I were to give room, I can take this and just pack it up there. Gets a little close, and I want that ground to be able to connect properly. This is going to want to come off at a cursed angle. Stop changing the tool. Keeps changing it on me. Yeah, it's like all I need to do is contact this giant area here, but the CAD program will not allow that to count. This is cursed. I need to move you up. Move it up, move it up, move it up. See, one thing that I do enjoy about this level of doing the CAD stuff is that it takes the brain out of the equation. You still need to have a lot to think about when making a circuit board, but this helps you keep your thoughts, you know, in the right place. Is that off? It's going to be off, isn't it? Oh yeah, that's cursed. Damn it. Get rid of all this stuff. Get out of my face. I need to take it to the grid better. Lear. They added an extra click for when you want to actually zap something, which I guess is good. That's a good feature. Yeah, it won't let me go from this area. I have to go from all the way over there. So we'll just try to hide it under a 0.3. There, just hidden in the alt spacing. Take a 0.4. Run in parallel. Is that cursed? No. It's pretty good. Pretty good. Pretty good. I'll just do that. Okay. And that's it for the air wires. We have wired up the entire circuit board. Look at that. So the next step is to put your ground plane in there. You do that with a polygon fill, and you enter the signal name as GND. GND. It's the same signal name that I put on the schematic. Isolate, no. Thermal width, I just leave those settings. I think that it knows what it's doing. The Seed Studio design rules are what brought in all of these numbers. Well, that's something that I can teach that you guys don't need to remind me of. So boom, we double click to end that task, and now all of our ground pour is populated, and we can see a little bit better of what the layer, it actually shows you what the layer is going to look like a little bit more. Looks like I do need to run traces inside of these. I'll do that later. And then the areas where ground is not reaching end up getting no fill at all. And so you can just take a via and you can rename it. I usually copy these other vias and just cut and paste them throughout. So if I copy that, it's going to make another via. I can plant it right there, and I can go to the properties and change the signal name to GND. Okay, it doesn't let me do that. I need to find something else that I can use. It was asking me if I wanted to, I want to change it. I don't want to, like, I guess it's like protected as a power trace. If I find another via, I could probably do that. Or I could just place a via with a via tool. There is a tool for that. Route. Via. Bonk. There it is. And then that fills in that area. And then I'll use various other vias in order to kind of staple stuff around. Now this is not coming in properly, so I need to actually go to the properties and I need to change it to a different rank. I don't think making it rank 2, yeah, that doesn't do it. I need to keep it at rank 1, which is the most important rank, and then I need to take my fill and I need to change that to rank 2. And that way, it'll avoid that area. And so I get that nice little grid pattern. So there's still a little bit of work for me to do here. I need to go through and I need to add vias and make sure that my pour is reaching everywhere that it needs to reach. I can then clean things up and sort of open things up as I need to. Now that I've got all of my traces going in proper directions, I can do things like move this, push this one out just a little bit so I can get a fill in here. And there too. And I can kind of just sort of massage things until they feel more professional in my mind, in my engineer mind. Most of the stuff done here is for appearances, but you know, some of it's functional, like stapling your grounds together help make your board a little bit more insusceptible to noise. Although on a circuit of this speed and the amount of signaling that's going around in this, it's not really going to make that much of a difference. And you know, I can identify pads that might be a little weaker to reworking and try to give a via to them and strengthen them up. But there's our top layer polygon pore that's going to shield our audio device. I mean, it is an audio device, so it would be prudent to move stuff around and kind of make sure everybody's happy and accommodated. So I'm going to save this. When am I on next? I'm on next on Thursday. So we've got Wednesday and then Thursday. I need to prioritize putting my computer back together because it fucking exploded. It didn't explode. Everything's fine, except I had to explode it. I had to pull it apart, piece by piece by piece by piece. Because I put a spring in one of the water lines as a stent in order to keep the tube from collapsing on itself. And that led to the spring, whose coating I thought was better. I'll never trust the spring coating again. But yeah, the spring, I should have nickel plated it. But the spring completely disintegrated and it left my entire water system with rust. So I'm putting in opaque fluid, and I've put a bunch of the parts into an ultrasonic cleaner to get all this stuff off of them. But I need my computer again. I need my computer so I can finish the circuit on my own. Anyway, thank you guys for joining me for like a modular synthesizer build. We can do the rendering really quick just to round it off. Done with that. Go like this. Push that over. There's a little bit of Z fighting that goes on in the final rendering, but Fusion has been slowly working on this stuff, and they're starting to get things better and better. I don't know if you can do a circular trace, like if you do a trace that's a circle, if that will render properly still. We had a lot of trouble with this thingy, the steering wheel adapter in that regard. There's our capacitors. Our 3-edge capacitors. Getting a little close there, buddy. I think that one needs to be moved just a little bit. Yeah, let's move that. I'm going to move that one while we're on the subject. So that's going to be hard to see. I can either delete those and bring them back. I think I might get away with just doing this. Yep, I can get away with it. Yeah, I'll keep it right there. And now I need to do the 3D PCB render. That's kind of a problem right there. Come on, buddy. There it goes. That's just gonna... There it goes. Bada bing. Yeah, that makes me a little bit more comfortable. So yeah, I need to do a bunch of massaging of the electronics there in order to get them to fit properly and look good and all that stuff. But getting there for sure. I'll probably be able to order this thing by early next week, maybe, or by next stream we can just get it ready to order, assuming that my computer is going back together properly. Okay, I will be back on Thursday. Thank you guys for joining me, and especially thanks for Last Mile's raiding. That was a very big raid. It brought a lot of people over here. Most of you guys, if you survived this stream, thank you. That was awesome. I did not expect the Last Mile's raid. I think one of the projects that we're going to need to work on soon is an alert bell for me, like an LED that'll come on and say raid or something like that. I need something like that. Yeah. Well, yeah, especially thank you guys for lurking and sticking it out. I appreciate you guys hanging out with me. I mean, my constant YouTube uploading has been kind of like an ego jab because I have to like observe my own streams and then look at how little traction they have. We had a bunch of YouTube chatters though today. It was awesome. I really appreciate you guys. Anyway, I'm going to be back on Thursday. I'm going to continue streaming on Thursday, and we have too much to do, not enough time to do them. I'm going to keep working on my PC on my own, but yeah. Share, like, subscribe. Come over to Twitch and follow me on Twitch. I will catch you guys later. Here's like what limited social media, whatever that is. That's all falling apart. Nobody does that anymore. And I periodically post stuff there, but the Discord link is the important one. That's where I will be between streams, so you guys can catch me there. And I guess this is where I do the bit where I actually flip to the scene where the microphone doesn't